2.5 million light-years away, in the velvet silence of the intergalactic void, something is watching us back. It is a presence that defies human scale, a cosmic island of such staggering proportions that our minds struggle to grasp its reality. The Andromeda galaxy, a shimmering tapestry of light and shadow, holds 1 trillion stars within its graceful, sweeping spiral arms. It is our closest major neighbor, a sister to our own Milky Way, yet it possesses a dark, hungry history that is only now beginning to be fully understood. At its very core, hidden behind veils of dust and the blinding light of millions of suns, sits a supermassive black hole. This gravitational titan is 140 million times more massive than our star, a concentration of matter so dense that it warps the very fabric of space and time around it. For decades, we viewed this neighbor as a distant, static beauty, a fixed point in the autumn sky. But the James Webb Space Telescope has changed everything. It has peered into the heart of Andromeda with its golden infrared eyes, stripping away the mysteries of the visible spectrum to reveal a truth that has rewritten our understanding of the COs. What scientists discovered there has sent a chill through the astronomical community. A sleeping monster is showing signs of waking. On a clear autumn night, if you travel far from the orange glow of city lights, you can see it with your naked eye. It appears as a faint, elongated smudge of light, nestled within the constellation Cassiopeia. Most people walk right past it, unaware that they are re-witnessing the combined glow of 1 trillion suns. They have no idea they are looking at a galaxy containing such an unthinkable number of worlds, all packed into a spinning disk 220,000 light-years across. The light hitting your retina tonight left those stars when our ancestors were barely human, before the first tools were knapped from flint, before the first fires were tamed. That light has raveled across the vacuum for millions of years just to find you. The Andromeda galaxy is our nearest major galactic neighbor, and it is coming straight toward us. For over a century, astronomers have meticulously studied this cosmic island. They have mapped its elegant spiral arms, counted its ancient star clusters, and measured its distance at roughly 2.5 million light-years from Earth. In the context of our daily lives, that distance sounds impossibly, almost absurdly far. Yet in the grand, sweeping terms of the cosmos, Andromeda is practically in our backyard. The Milky Way and Andromeda are the 2 largest galaxies in what scientists call the local group, a collection of more than 50 galaxies bound together by the invisible threads of gravity. But here is the detail that makes your spine tingle, a fact that hums with a quiet, terrifying energy. Andromeda is not standing still, nor is it drifting aimlessly. Every single second it races toward us at roughly 70 miles per second. That is over 250,000 miles per hour. At that speed you could circle the entire Earth 10 times in just 60 minutes. The galaxy has been on this relentless collision course for billions of years, drawn by an irresistible gravitational attraction. Nothing in the universe can stop what comes next. The James Webb Space Telescope changed the narrative entirely when it turned its hexagonal mirrors toward this approaching giant. Unlike Hubble, which sees the universe in the visible light that human eyes perceive, Webb operates in the infrared. It sees heat signatures, hidden structures, and ionic stars that have been invisible to every instrument that came before it. It sees the galaxy's bones, not just its skin. When Webb focused its gaze on the core of Andromeda, scientists expected to observe a sleeping giant. They anticipated a quiet galactic center, a dormant nucleus minding its own business across the vastness of the void. They were profoundly wrong. What the data revealed sent shockwaves through the scientific world. The images showed something stirring at the heart of Andromeda. Unusual bursts of radiation, distorted clouds of gas, and structures that should not exist according to our standard models of galactic behavior. One researcher described the incoming data as deeply unsettling. Another called it the most significant discovery about Andromeda in decades. The telescope captured details no human instrument had ever glimpsed before. filaments of superheated material spiraling inward toward an invisible point, dust rings glowing with intense infrared light, and star clusters behaving in ways that defied traditional explanation. And at the very center of it all, wrapped in layers of gas and the light of ancient stars, sat the monster itself. This supermassive black hole is not just a passive object, it is a force of nature that may be waking up from a multi-million-year slumber. The implications of this awakening are staggering. If this black hole is increasing its activity, it could reshape the entire internal structure of the galaxy long before our two cosmic islands ever make physical contact. But the truly terrifying part, the revelation that has forced astronomers to rethink their timelines, is that the collision between Andromeda and the Milky Way might be far more violent, more chaotic, and much closer than anyone had predicted. Your eyes are in many ways liars. They show you less than 1% of what actually exists in the universe. The visible spectrum, the rainbow of colors you see in a sunset or a flower, represents just a thin, fragile slice of electromagnetic radiation. Most of the universe operates in frequencies you will never see. This is where the story of the James Webb Space Telescope truly begins, as it enables us to bridge the gap between the seen and the unseen. Launched in December 2021, Webb does not look at the universe as you do. Its instruments are finely tuned to infrared wavelengths, the heat signature, the cosmos itself. This gives the telescope a superpower that its predecessors lacked. It can peer through the thick, suffocating clouds of cosmic dust that block visible light completely. Imagine trying to see through a dense grey fog with your eyes. It is impossible, the light simply scatters and reflects. Now, imagine having thermal vision that detects heat instead of light. Suddenly, the G becomes transparent, and the world behind it is revealed in stark, glowing detail. That is exactly what Webb does when it looks at Andromeda. It sees through the dust lanes that appear dark and empty in visible light, revealing that they are actually packed with material. These lanes are teeming with cool stars, molecular clouds, and complex organic compounds, the very building blocks used to construct new solar systems and perhaps the life that might one day inhabit them. As we stand on the threshold of this new era of discovery, we must accept that our peaceful neighbor is a predator with a violent past and an active future. The golden mirrors of Webb have pulled back the curtain, and what we see is a galaxy in flux, a system that is far more dynamic and dangerous than we once dared imagine. The gaze from the abyss is a two-way street. As we look deeper into the heart of Andromeda, we are forced to confront the reality of our own place in the universe. We are part of a grand unfolding drama, a collision of titans that began long ago and is now entering its most critical phase. The quiet smudge in the sky is a warning, a beautiful and terrifying reminder of the forces that govern the dark. We are no longer just observers, we are participants in a cosmic event that will eventually consume our home. For now, the stars continue to burn, and the black hole continues to stir, waiting for the moment when the two galaxies finally become one. To understand the true nature of the Andromeda galaxy, one must first confront the terrifying reality of its motion. In the silent, frozen theater of the night sky, everything appears static, a fixed map of light that has remained unchanged for all of human history. But this stillness is a profound illusion born of our short lifespans and the vast distances between the stars. In truth, we are living in a neighborhood defined by incredible, violent velocities. Andromeda is not merely a distant neighbor, it is a cosmic projectile of unimaginable mass, hurtling through the vacuum with a singular, relentless purpose. It is racing toward the Milky Way at a speed that boggles the mathematical mind, 70 miles every single second. To visualize this, imagine a jet spanning the entire width of a continent in the time it takes you to blink. At 250,000 miles per hour, this galaxy, a structure containing 1 trillion suns and a supermass black hole, is closing the gap between us with the inevitability of a falling stone. This speed is not just a random statistic, it is the heartbeat of a cosmic tragedy that has been unfolding for billions of years. For over a century since the dawn of modern spectroscopy, astronomers have observed Andromeda light, They noticed a phenomenon known as blue shift. In the language of physics, when an object moves away from an observer, its light stretches, shifting toward the red end of the spectrum. But when an object rushes toward you, its light waves compress, shifting toward the blue. Andromeda's light is a deep, consistent blue. This was the first warning sign that the distance between our two galaxies was shrinking. For eons, the gravity of the Milky Way and the gravity of Andromeda had been locked in a silent tug-of-war. Because they are the two most massive entities in our local group, they act like two magnets placed on a frictionless surface. They are fated to meet, drawn together by an invisible thread that nothing in the known universe can sever. When we speak of 1 trillion stars moving at such speeds, the numbers begin to lose their meaning, slipping into the realm of abstract. If you were to count one star every second without eating, sleeping, or pausing for breath, it would take you more than 30,000 years to finish the count for Andromeda alone. Now, imagine that entire assembly of nuclear furnaces, planetary systems, and gas clouds moving as a single cohesive unit through the dark. The kinetic energy involved is so vast that it defies calculate. It is a momentum that could flatten entire clusters of smaller galaxies, and indeed, as we look closer at Andromeda's structure, we see that it has done exactly that. Its speed is a testament to its hunger. It has traveled through the local group like a predator, its velocity governed by the mass it has consumed along the way. Every dwarf galaxy it has swallowed has added to its gravitational pull, making its descent toward us more powerful with every passing billion years. The James Webb Space Telescope has provided a new perspective on this velocity. By looking at the movement of individual star clusters and gas clouds within Andromeda, Webb has shown us that the galaxy is not just moving toward us as a flat disk. It is a churning, boiling cauldron of internal motions. The stars at the edges of the galaxy are being whipped around by the central mass, while the gas in the spiral arms is being compressed by the sheer pressure of its travel through the intergalactic medium. Even the void between galaxies is not truly empty. It is filled with a thin, ionized plasma. As Andromeda screams through this medium at 250,000 miles per hour, it creates a bow shock, a massive wave of pressure that heats the gas in front of it to millions of degrees. We are not just approaching a galaxy, we are approaching a storm front of cosmic proportions. This violent speed brings with it a sense of profound cosmic dread when one considers the timeline. While 4 billion years feels like an eternity in the context of a human life, in the life of a galaxy, it is the blink of an EY. The collision course was set long before the Earth was formed, long before the Sun ignited in the darkness of a molecular cloud. We are currently living in the final quiet moments before the storm breaks. Astronomers have used the most powerful supercomputers on the planet to simulate this approach, and the results are consistently beautiful and horrifying. As the gap closes, the mutual gravity of the two galaxies will begin to pull at their outer edges. The elegant spiral arms we see today will be the first things to go, stretched into long, thin ribbons of starlight called tidal tails. These ribbons will bridge the gap between the two systems, creating a highway of stars that will span millions of light years. The reason this speed is so terrifying to scientists is that it leaves no room for escape. In the early days of astronomy, some hoped that Andromeda might have a slight sideways motion, a tangential velocity that would cause it to miss us, swinging past like a ship in the night. But recent data from the Gaia spacecraft and the Hubble Space Telescope, now supplemented by the precision of Webb, has narrowed the margin of error. The sideways motion is minimal. It is a near, direct hit. We are standing on the tracks, and the headlight of the train is the glow of 1 trillion suns. The speed is so great that once the galaxies enter each other's gravitational sphere of influence, they will accelerate even further. The final plunge will be a chaotic scramble of stars and gas, a dance of destruction that will redefine the meaning of the word impact. As you listen to the essay words, remember that this motion is happening right now. While the world outside your window seems still and the stars above seem fixed, you are currently part of a galactic system that is falling toward its neighbor. We are in a state of perpetual cosmic freefall. The speed of Andromeda is a reminder that the universe is not a static place of peace, but a dynamic, evolving environment where gravity is the ultimate law. The James Webb Space Telescope has allowed us to see the subtle distortions in the gas of Andromeda that are caused by this high-speed travel. We see filaments of dust being stripped away, trailing behind the galaxy like the hair of a ghost. These are the physical manifestations of velocity, the scars of a journey that has lasted over 10 billion years. The sheer scale of this movement serves to put our own existence into a humbling perspective. Our entire history, from the first spark of life in a primordial ocean to the most advanced technology we possess today, has taken place while we were falling toward Andromeda. The rise and fall of empires, the discovery of fire, the composition of symphonies, all of it has occurred within this relentless high-speed approach. We are passengers on a solar system that is itself a passenger on a galaxy, hurtling through the dark at speeds that should be impossible. And yet, there is a strange, cold comfort in this reality. Our neighbor's speed ensures that the universe is never bored. It is a guarantee of change, a promise that the future will look nothing like the past. The violent speed of Andromeda is the engine. Creation, the force that will eventually melt two galaxies down and forge something entirely new from their remains. As we look out across the 2.5 million light-years that remain, we see not a peaceful neighbor, but a titan in mid-stride. The light we see is the light of a hunter. The James Webb Space Telescope continues to track this motion, measuring the subtle shifts in infrared that reveal how the galaxy's internal structure is reacting to its own momentum. We are watching the physics of the impossible play out in real time. The journey is far from over, but the destination is certain. The speed of Andromeda is the clock by which our galaxy's life is measured, and with every passing second, the ticking grows louder in the silence of the void. The launch of the James Webb Space Telescope marked the end of our cosmic blindness, a moment when humanity finally traded its cataracts for a vision that could pierce the very shroud of the universe. To understand why what it saw in Andromeda was so terrifying, one must first understand the instrument itself. Unlike the telescopes of the past, which relied on the same visible light that bounces off our skin and fills our rooms, Webb was designed to operate in the realm of the invisible. It is an infrared creature. Its primary eye is a massive honeycombed array of 18 hexagonal segments, coated in a layer of gold just a few atoms thick. This gold is not for vanity, it is the most efficient material for reflecting infrared light back into the telescope's sensors. In the cold, dark silence of space, nearly a million miles from Earth, these golden mirrors act as a bucket, catching the faint, stretched-out heat signatures of objects that have been traveling toward us since the dawn of time. For decades, the Hubble Space Telescope was our primary window into the Andromeda galaxy. Hubble's images were iconic, swirling vistas of blue stars and dark, winding dust lanes. But those images, as beautiful as they were incomplete. Visible light is easily blocked. A single cloud of interstellar dust can act as a brick wall, hiding thousands of stars and entire planetary nurseries from view. To Hubble, the core of Andromeda looked like a bright, opaque smudge, a mystery hidden behind a veil of cosmic soot. But to Webb, that soot is transparent. Infrared radiation has a longer wavelength than visible light, allowing it to slip between the microscopic grains of dust like a ghost passing through a closed door. When the James Webb Space Telescope turned its golden mirrors toward Andromeda, it did not just see the galaxy, it performed an autopsy on it. It peeled back the layers of dust to reveal the hidden anatomy of our neighbor. It was in this hidden layer that the terrifying reality began to take shape. The transition from visible to infrared is like switching from a standard camera to a thermal imaging lens in a pitch-black forest. Suddenly, things that were cold and dark become glowing silhouettes of energy. In the infrared, The dark dust lanes of Andromeda's spiral arms do not look like shadows. They glow with a haunting internal heat. Webb's mid-infrared instrument, known as MIRI-A, ND, its near-infrared camera, or NIRCam, work in tandem to dissect these heat signatures. NIRCam is designed to see the stars themselves, specifically the older, redder stars that dominate the galaxy's mass, but are often too dim for visible light telescopes to resolve. MIRI, on the other hand, detects the glow of the dust itself, the complex organic molecules, and the heat of newborn stars still trap, paired in their birthing cocoons. Together, these instruments created a multi-layered map of Andromeda that was so detailed it felt invasive. Scientists were no longer looking at a distant object. They were looking at the internal gears of a machine that was beginning to grind and smoke. What Webb's golden mirrors caught was a level of turbulence that defied all previous simulations. In the visible S-spectrum, a galaxy's core often looks peaceful, a steady glow of ancient, reliable suns. But in the infrared, Webb saw a chaotic gas rush. It saw massive filaments of hydrogen being pulled and twisted by gravitational forces that shouldn't have been that active in a dormant galaxy. These structures looked like frayed wires in a high-voltage circuit. The precision of the telescope allowed astronomers to measure the temperature of these gas clouds down to tiny fractions of a degree. They found hot spots in places where the galaxy should have been cold and quiet. This was the first evidence that the sleeping monster at the center of Andromeda was not merely dreaming, it was stirring, and its movements were rippling through the entire inner 3,000 light-years of the galaxy, the IN. Flared eyes of Webb also revealed the presence of ghost structures, remnants of galaxies that Andromeda had eaten in the past, which were still being digested in its inner regions. These are invisible to the naked eye because they consist of cool, thin gas that doesn't emit much visible light, but in the infrared they glow with a faint, sickly heat, like the embers of a dying fire. Seeing these scars in such high resolution was deeply unsettling for the researchers. It provided a visual confirmation of Andromeda's predatory nature. The telescope showed that the galaxy is not a static collection of stars, but a living, breathing, and consuming entity. The golden mirrors captured the feeding tubes of the galaxy, long winding streams of matter that are currently being funneled toward the central black hole. This discovery was the primary reason the word terrified began to appear in scientific discussions. If the feeding was happening now, it meant the black hole was waking up much faster than anyone had anticipated. Furthermore, Webb's vision allowed us to see the great plain of Andromeda in a way we never could before. This is a thin, rotating disk of satellite galaxies that orbit Andromeda in a way that defies the laws of standard dark matter physics. In the infrared, the interactions between these smaller galaxies and Andromeda's main body became clear. We saw the bridges of gas being ripped out of the satellites, creating a web of connections that looked like a spider's silk. This web is a sign of an active, ongoing merger process. The telescope showed us that TE collision isn't just a future event. It is a current state of being. The infrared eyes of Webb revealed that the boundaries between galaxies are much fuzzier and more violent than our eyes lead us to believe. We are seeing a slow-motion car crash that has already reached the point where the metal is beginning to crumple. The sheer sensitivity of Webb is difficult to overstate. It is capable of detecting the heat of a single bumblebee on the moon. When that level of sensitivity is pointed at 1 trillion stars, the amount of data is overwhelming. Every pixel in a Webb image of Andromeda contains information about the chemical composition, temperature and velocity of thousands of objects. Scientists found themselves drowning in a sea of anomalies. They found stars that were moving too fast, gas that was too hot, and holes in the interstellar medium that suggested something massive and invisible had recently punched through. These were the clues that led to the realization that the supermassive black hole at the center, the 140 million solar mass Titan, was exerting a far more direct influence on the galaxy's daily life than previously thought. As the telescope continues to beam its Back to Earth, the image of Andromeda is shifting from a celestial masterpiece to a cautionary tale. The golden mirrors have acted as a magnifying glass, showing us the cracks in the foundation of our galactic neighbor. We have learned that the infrared universe is a place of violence, heat, and constant motion. The terrified reaction of the scientists was not born of superstition, but of sudden, stark clarity that Webb provided. They were seeing the truth of the cosmos for the first time, stripped of the comforting veil of visible light. The golden mirrors showed us a galaxy that is waking up, and in that awakening, we see a preview of our own eventual fate. The eyes of Webb are never shut. They continue to stare into the dark, watching the monster as it prepares for the next ace of its life. Numbers lose their practical meaning when we attempt to apply them to galactic scales, and nowhere is this more evident than when we contemplate the sheer density of the Andromeda galaxy. Your brain is a remarkable instrument of evolution, but it was never designed to comprehend what a trillion actually looks like. If you were to sit down today and begin counting the stars of Andromeda one by one at a rate of 1 star per second, without ever sleeping, eating, or stopping for breath, you would not finish your task for 31,700 years. That is how many nuclear ovens are burning in our nearest neighbor now. While our own Milky Way is a majestic city of light, Andromeda is a sprawling metropolis, nearly twice as populous. Each of those trillion ints of light is a churning, boiling sphere of plasma, a nuclear reactor held together by the crushing force of its own gravity. Together, they create a collective heat and light that can be seen across the terrifying expanse of 2.5 million light-years of empty space. The James Webb Space Telescope has turned this blurry smudge of light into a high-definition catalogue of stellar diversity. Not all stars in this trillion-star furnace are created equal. Most of the stars that make up the bulk of Andromeda are smaller and cooler than our own Sun, ancient red dwarfs that burn their hydrogen fuel so slowly and efficiently that they will remain shining for trillions of years, long after the universe has grown cold and dark. But sprinkled among these reliable embers are the blue giants, the cosmic rock stars. These massive suns shine with a fierce, unstable brilliance, often radiating 10,000 or even 100,000 times the luminosity of our star. They are the engines of change, living fast and dying young, destined to end their lives in spectacular supernova explosions that enrich the galaxy with heavy elements. Webb's infrared eyes allow us to see these stars not as a single glow, but as distinct populations, each telling a different story about the galaxy's turbulent history. The sheer mass of all these stars is staggering, yet they are all held in a delicate, spinning dance by the invisible hand of gravity. Andromeda contains roughly 1.5 trillion times the mass of our star when you account for the stars, the gas, and the vast, invisible halo of dark matter. That outweighs the visible matter by a ratio of 6-to-1. The Milky Way, by comparison, holds only about 800 billion stellar masses. This difference in mass is the reason Andromeda is the undisputed predator of the local group. In cosmic physics, mass is power. It determines who stays and who goes, who eats and who is eaten. When the two galaxies eventually meet, Andromeda's superior mass means it will be the dominant partner in the collision. It is a cosmic heavyweight entering the ring against a lighter opponent, and its trillion stars act as a massive gravitational net that is already beginning to entangle our own outer fringes. What makes the star furnace of Andromeda particularly fascinating to scientists is how differently it produces new life compared to our own galaxy. Our Milky Way is a relatively productive factory, creating roughly 7 new stars every year. Andromeda, despite its much larger size, is curiously sluggish, producing only 2 or 3 stars in the same time frame. Astronomers theorize that this stellar infertility is a scar from a violent event in its past. Several billion years ago, Andromeda appears to have undergone a major collision with another large galaxy, an event so intense that it used up the vast majority of its available hydrogen gas. With the fuel for star formation depleted, the galaxy began to settle into a middle-aged quiet. However, the James Webb Space Telescope has discovered something that contradicts this narrative of a dying galaxy. In certain pockets of the spiral arms, hidden deep within cocoons of dust that no other telescope could penetrate, Webb revealed starburst regions where new suns are being born at an explosive rate. These stellar nurseries are far more active than anyone predicted. The telescope can detect the heat of these newborn stars as they blast their surroundings with ultraviolet radiation, causing the nearby dust to glow with a haunting infrared light. Why would a galaxy that should be quiet suddenly start producing stars in such concentrated bursts? One leading theory suggests that the gravity of Andromeda's satellite galaxies is compressing the gas clouds as they orbit, acting like a cosmic bellows that reignites the furnace. Another, more unsettling theory is that the galaxy's own internal structure is responding to the upcoming collision with the Milky Way, with the two galaxies' gravitational fields starting to squeeze the gas into dense star-forming clumps long before the stars themselves ever meet. The temperature readings provided by Webb are perhaps the most revealing part of this data. In a stable galaxy, you expect a predictable gradient of heat moving out from the core. But in Andromeda, Webb found temperature anomalies, regions that should be cooling down but are instead spiking in heat. These are the signatures of massive clusters of young stars that were previously invisible. These stars are so hot and so numerous that they are physically pushing the surrounding gas out of the galaxy, creating bubbles in the interstellar medium. The trillion-star furnace is not a static object, it is a boiling, expanding pressure cooker. Each of these stars contributes to the total gravitational potential of the galaxy. As they whip around the center at hundreds of miles per second, they create a collective energy that warps space-time around the entire local group. When you look at Andromeda through the lens of Webb, you aren't just seeing light, you are seeing the fossilized remains of everything the galaxy has ever done. The metal-rich stars tell of past soup rovers, while the ancient, metal-poor stars in the outer halo speak of a time when the universe was young. This trillion-star assembly is a living record of galactic evolution. It is a furnace that has been burning for over 12 billion years, and it is currently being stoked for its final, most violent act. As we map these stars, we are essentially mapping the ammunition that will be used during the merger with the Milky Way. Every star is a projectile, and with 1 trillion of them heading our way, the scale of the impending impact is almost impossible to overstate. The truly terrifying part of this discovery is the realization that we are not just looking at a collection of suns, but at a singular, massive organism governed by the black hole at its heart. Stars are the galaxy's flesh. Gravity is its soul. The trillion stars of Andromeda provide the fuel and mass that feeds the monster at its center. They are the reason the central black hole is so massive it has spent eons snacking on the stars that wandered too close to its event horizon. As Webb continues to resolve individual stars in the outermost regions, it is becoming clear that the boundaries of this trillion-star furnace are much wider than we ever imagined. The furnace is growing, its heat is reaching out across the void, and its trillion eyes are fixed firmly on us, at the exact center of Andromeda. In a region of space that would comfortably fit within the boundaries of our own solar system, sits an object that defies every law of common sense and every intuition of human experience. It is a place where physics breaks, where time stretches to a standstill, and where the light of 1 trillion stars goes to die. This is the supermassive black hole of Andromeda, a gravitational titan with a mass estimated at 140 million times that of our Sun. To understand the sheer monstrosity of this object, one must compare it to the heart of our own galaxy. Sagittarius, a star, the black hole at the center of the Milky Way, is a formidable beast, weighing roughly 4 million solar masses. It is powerful enough to fling entire suns around like pebbles in a slingshot. Yet, the monster at the heart of Andromeda is 35 times more massive. It is not merely a larger version of our own central black hole, it is a predator of a different order entirely, a concentration of matter so dense that it has warped the very architecture of the galaxy around it. For most of human history, and indeed for most of the life of our species, this monster has been considered asleep. Black holes do not actually sleep, of course, but they can exist in a state of dormancy where they are not actively consuming large amounts of material. When a black hole is quiet, it is nearly invisible, detectable only by the way its gravity tugs on the stars nearby. For millions of years, the central black hole of Andromeda has sat in the darkness, occasionally snacking on a stray gas cloud or a wandering, unlucky star. Astronomers compared it to a resting predator, a lion in the tall grass of the cosmic savanna. But the James Webb Space Telescope, along with high-energy X-ray observatories, has revealed that this period of our est is coming to a violent end. The monster is stirring. The baseline radiation coming from the core has shifted, and the breathing of the black hole, the way it emits energy as matter falls into its maw, has become more labored and intense. The physical scale of this object is as terrifying as its mass. The event horizon, that invisible boundary representing the point of no return, expands in ECT proportion to a black hole's mass. For our own central black hole, the event horizon has a radius of about 12 million miles. You could fit 17 suns side by side across that distance. However, the event horizon of the Andromeda monster stretches over 4000 million miles across. This sphere of doom is wider than the planet Mars' orbit around our Sun. If our solar system were placed inside Andromeda's core, the black hole would swallow the Sun, Mercury, Venus, Earth, and Mars instantly, without even noticing the increase in its mass. Anything crossing that 400 million mile boundary is gone forever, removed from the observable universe. It is not destroyed instantly in the way we might imagine an explosion. Instead, it undergoes the process physicists call spaghettify. Cation. The tidal forces are so extreme that the gravity pulling on the front of an object is significantly stronger than the gravity pulling on the back, stretching stars, planets, and atoms into long, thin ribbons of matter before they are consumed by the singularity. Scientists measured the mass of this hidden titan by observing stars that live in the danger zone of the galactic center. These stars orbit at incredible speeds, sometimes exceeding thousands of miles per second, as they are whipped around by the invisible central weight. By tracking these elliptical paths over decades, astronomers calculated that 140 million stellar masses must be packed into that tiny dark volume. The discovery of this black hole was first hinted at in 1991, when the Hubble Space Telescope looked at the nucleus and saw something bizarre. The center of Andromeda appeared to be double. There were two bright concentrations of stars where there should have been only one. For years, the scientific community debated if Andromeda had two black holes or if it had recently swallowed another galaxy. Eventually, the truth was revealed. There is only one monster, but its gravity is so intense that it has seed the surrounding stars into a lopsided, eccentric disk. This disk creates the optical illusion of two cores, but in reality, it is just a sign of the monster's overwhelming influence on its environment. What makes this monster terrifying to the researchers operating the James Webb Space Telescope is the evidence that it is starting to feed more frequently. The telescope's infrared sensors have detected long, elegant filaments of gas and dust stretching from the outer regions of the galaxy toward the center. These are not random clouds, they are feeding tubes. Matter is being funneled into the core at an accelerating rate. As this gas falls toward the event horizon, friction and magnetic fields heat it to thousands, then millions of degrees. It begins to glow with a fierce infrared here. Before it reaches the point where it emits the X-rays that Chandra and other observatories have detected, we are seeing the beginning of a transition. If the feeding rate continues to rise, the dormant black hole will transform into an active galactic nucleus. It will become a quasar, one of the brightest and most destructive objects in the universe. Waking the monster has profound implications for the rest of the galaxy. An active black hole does not just swallow matter, it also screams. As material is crushed and heated in the accretion disk just outside the event horizon, it releases enormous amounts of energy. This radiation can be so intense that it physically pushes gas out of the galaxy, a process that can shut down star formation and kill the galaxy from the inside out. Webb has already seen signs of this galactic wind beginning to stir in Andromeda's core. The gas clouds near the center are moving faster than they should, pushed by the rising pressure of the radiation coming from the black hole's vicinity. The monster is starting to exhale, and its breath is a scorching wind of high-energy particles that could reshape the future of the entire trillion-star system. P.E. Perhaps the most unsettling realization is that this black hole is itself a product of ancient violence. The strange double nucleus structure and the eccentric orbits of the nearby stars suggest that Andromeda's black hole merged with another supermassive black hole in the distant past, perhaps several 100 million years ago. This means the monster we see today is a hybrid, a survivor of a previous galactic collision. It has already tasted the power of a merger, and it is now preparing for the next one. When the Milky Way and Andromeda eventually collide, our 4 million solar mass black hole will be drawn toward this 140 million solar mass giant. They will enter a long, slow orbital dance, spiraling closer and closer together until they finally merge. The smaller black hole will be consumed by the larger one, and the resulting eruption of gravitational waves will be felt across the entire observable universe. As we stare into the heart of Andromeda through the golden mirrors of Webb, we are looking at the ultimate destination of all matter in that galaxy. The stars, the gas, the planets, and eventually our own home are all being drawn toward this central point of infinite density. The monster at the heart is the silent conductor of the galactic orchestra, and its song is one of gravity and shadow. It sits there, 400 million miles of absolute darkness, surrounded by a swirling fire of gas and stars, waiting for the moment when it no longer has to snack on filaments, but can feast on an entire galaxy. The waking of this beast is a signal that the era of quiet boreliness is over. The centerpiece of the Andromeda mystery is no longer a dormant relic, but an active participant in the coming chaos. To truly grasp the magnitude of the changes occurring within Andromeda, we must look beyond the golden light of the stars and the warm glow of infrared dust. We must descend into the realm of high-energy physics, where the universe speaks in the language of X-ray and ghost particles. While the James Webb Space Telescope provides a structural map of the galaxy, other sentinels are watching the core in frequencies that would be lethal to organic life. The Chandra X-ray Observatory has been staring at the heart of Andromeda for over 2 decades, and the story it tells is one of increasing violence. In the visible world, a black hole is a void, but in the X-ray spectrum, it is a beacon. As matter is accelerated to significant fractions of the speed of light, it reaches temperatures of tens of millions of degrees, emitting high-energy X-rays that can penetrate through almost anything. For 15 years, Chandra recorded a steady, dim hum from Andromeda's core. But in 2006, the silence was shattered. The X-ray brightness spiked by a factor of 100, in a matter of hours, signaling a massive feeding event that sent ripples of radiation across the galactic center. This was not an isolated incident. In 2013, another powerful flare erupted, and this time it was accompanied by something even more elusive and mysterious: neutrinos. These are the ghost particles of the cosmos, subatomic, nearly massless, and possessing no electrical charge. Neutrinos are produced in the most extreme environments imaginable, places where matter is being torn apart at the subatomic level. They are so indifferent to normal matter that trillions of them are passing through your body at this very moment, having traveled from the hearts of distant suns or the edges of black holes without ever touching a single atom of your being. To detect them, humans had to build the Ice Cube Neutrino Observatory, a massive array of sensors buried a mile deep in the Antarctic ice. In 2013, IceCube detected a burst of high-energy neutrinos originating from the exact direction of Andromeda's core. This correlation changed everything. X-rays tell us that gas is getting hot, but neutrinos tell us that particles are being accelerated to energies millions of times higher than anything we can achieve in our most advanced particle accelerators on Earth. The arrival of these ghost particles suggests that the monster is doing more than just eating. It is acting as a cosmic cannon. When a supermassive black hole enters an active phase, magnetic fields near the event horizon can become so twisted and compressed that they act like a slingshot, launching protons and electrons into space at nearly the speed of light. When these ultra-fast particles collide with the surrounding gas and light, they create a cascade of subatomic debris, including the neutrinos that eventually found their way to the Antarctic ice. This is the terrifying discovery that moved the conversation from abstract astronomy to immediate physics. It means that our neighbor's heart is currental, home to a natural particle accelerator of unimaginable power. The fact that we are seeing these bursts now, after decades of relative quiet, suggests that Andromeda's inner environment is reaching a tipping point. The X-ray data from 2025 has confirmed that the black hole's baseline activity has not returned to its pre-2006 levels. It is as if the galaxy has developed a fever that refuses to break. Scientists are now observing hard X-rays, which indicate even higher energy levels and more compact, violent regions of emission. These signals are the fingerprints of a system in transition. If you were standing near the center of Andromeda, the sky would not be black. It would be a blinding, lethal haze of high-energy radiation. The ghost particles provide a unique window into this chaos, because they travel in perfectly straight lines. Unlike light, which can be bent by gravity or scattered by dust, a neutrino travels from the point of its creation to the detector without deviation. They are direct messengers from the abyss, and their message is that the energy density at Andromeda's core is rising. This high-energy activity has a profound effect on the galactic ecology of Andromeda. X-rays are ionizing radiation. They strip electrons away from atoms, changing the chemistry of the gas clouds that form new stars. When the central black hole flares, it sterilizes the inner regions of the galaxy, blasting them with a death ray of radiation that can last for thousands of years. We are seeing the beginning of a feedback loop. As more gas falls toward the center, the radiation increases, which in turn pushes back against the infalling gas, creating a turbulent, boiling environment. The James Webb Space Telescope has captured the infrared glow of the gas being pushed by this X-ray pressure. It looks like a series of concentric waves, a cosmic ripple effect emanating from the point where the neutrinos are born. The detection of these particles also forces us to reconsider the timeline of the upcoming merger. High-energy particles and X-rays can travel faster and farther than the stars themselves. We are already being bathed in the invisible exhaust of Andromeda's awakening. While the visible stars of the two galaxies are still millions of light-years apart, the high-energy particles being launched from Andromeda's core are already crossing the void. In a sense, the first scouts of the Andromeda invasion have already arrived on Earth. They are the neutrinos that pass through our planet every day, silent witnesses to the violence occurring in our neighbor's heart. Scientists are now monitoring these ghost particles with increased urgency, looking for a steady stream that would indicate the black hole has fully transitioned into a quasar state. The most disturbing aspect of neutrino detections is what they imply about the invisible structures of the galaxy. To produce such high-energy particles, you need more than just a black hole. You need a massive, coherent magnetic field. This suggests that Andromeda has a magnetic skeleton that is far more powerful and organized than previously thought. This field acts like a cage, trapping particles and whipping them into a frenzy before releasing them as a burst of neutrinos. As we study these signals, we are beginning to map this invisible cage. We are realizing that the space between the stars is not empty, but is filled with a web of energy that is beginning to glow with the heat of the approaching collision. The X-rays and ghost particles are the early warning sirens of the cosmos, signaling that the sleeping monster is no longer just dreaming. As we move forward in our analysis, we must keep our eyes on both the golden light of the mirrors and the blue flashes in the Antarctic ice. One shows us the galaxy's beauty, while the other shows us its power. Together, they paint a picture of a neighbor that is far more active and dangerous than we ever dared to imagine. The neutrinos are a reminder that the universe does not care about our comfort or our limited vision. It operates on an energy scale that is both magnificent and terrifying. Andromeda is currently the primary stage for this high-energy drama. The ghost particles have spoken, and they have told us that the heart of the abyss is wide awake. Mass warps reality, and at the center of Andromeda, the warping is so severe that the fabric of space-time has been shredded into a terminal puncture. To understand the anatomy of the event horizon surrounding Andromeda's supermassive black hole, one must first abandon the terrestrial concepts of distance, time, and solid matter. An event horizon is not a physical surface like the crust of a planet, it is a mathematical boundary, a point of no return where the escape velocity required to flee the gravitational pull exceeds the speed of light. Because nothing in the universe can travel faster than light, anything that crosses this threshold is effectively deleted from our reality. In Andromeda, this sphere of doom is an absolute void 400 million miles across, a diameter that would comfortably swallow the orbit of Mars. Within this dark boundary, the laws of physics, CS as we know them, cease to function, replaced by a singularity of infinite density where the very concepts of up and down or before and after lose all meaning. The James Webb Space Telescope, while unable to see inside the horizon, has provided the most detailed look yet at the chaotic anatomy just outside its edge. Surrounding the 400 million mile void is a swirling incandescent structure, known as the accretion disk. This disk is composed of gas, dust, and the mangled remains of stars that have been drawn into the monster's influence. As this material spirals toward the event horizon, it is accelerated to significant fractions of the speed of light. Friction between particles moving at these relativistic speeds generates heat that can reach billions of degrees. This is the ultimate irony of a black hole. The darkest object in the universe is often surrounded by the most brilliant light. Webb's infrared instruments have captured the glow of this region, revealing a complex network of magnetic fields that act as a high-pressure plumbing system, funneling matter toward the abyss, while simultaneously launching jets of radiation into the far reaches of the galaxy. One of the most terrifying aspects of the anatomy of this event horizon is the phenomenon of spaghettification, a term that sounds whimsical but describes a process of unimaginable violence. Because the gravity of Andromeda's black hole is so concentrated, the difference in gravitational pull over a short distance is extreme. If an object, even a massive star, were to approach the event horizon, the side close to the black hole would experience a pull significantly stronger than the side farther away. This tidal force would stretch the object into a thin, agonizingly long strand of plasma. In the case of Andromeda, this process happens on a scale that defies comprehension. Webb has observed tidal disruption events, where a star that wandered too close was shredded into a stream of glowing gas that wrapped around the event horizon like a ribbon of fire. These events provide a direct look at the monster's appetite, showing us exactly how it harvests the mass of the trillion-star furnace to grow even larger. Beyond the physical shredding of matter, the anatomy of the event horizon involves the warping of time itself. According to Einstein's general relativity, gravity slows the passage of time. Near the event horizon of a 140 million solar mass black hole, this effect, known as gravitational time dilation, becomes extreme. If you were to watch a star falling toward the horizon from a safe distance, you would never actually see it disappear. Instead, as it approached the boundary, the star would appear to slow down. Its light would shift into longer, redder wavelengths until it became a frozen crimson ghost on the edge of the void. To the star itself, however, the end would come in an instant. This disconnect between observer and observer is one of the many ways the Andromeda monster breaks our understanding of the universe. The James Webb Space Telescope has allowed us to see the redshift of the gas in this inner region, providing observational proof that time is indeed behaving strangely in the presence of such overwhelming mass. The sheer size of Andromeda's event horizon also means that its tidal forces are, paradoxically, less sharp at the edge than those of a smaller black hole. For a small black hole, the tidal forces would tear you apart long before you reach the horizon. But for a giant like the one in Andromeda, the event horizon is so large that a human, or even a small planet, could theoretically cross the boundary before being shredded. You would slip into the dark, forever severed from the universe, and only then would gravity begin its final lethal work. This soft horizon is a hallmark of supermassive black holes, and it makes them even more deceptive. They are vast, silent traps in the dark, and Webb's mapping of the central star clusters shows that many suns are already caught in the outer layers of this trap, doomed to a slow, spiraling descent that will last millions of years. The anatomy of this region is further complicated by the presence of a photon sphere, a region just outside the event horizon where gravity is so strong that photons are forced to travel in orbits. If you were standing in this sphere, you could theoretically see the back of your own head, as the light you emit would travel in a circle around the black hole and return to your eyes. Webb's data suggests that this region is filled with high-energy radiation, a shimmering halo of light that marks the final frontier of the physical world. This is where the X-ray flares detected by other observatories originate. When magnetic field lines in this photon sphere snap and reconnect, they release a burst of energy that outshines the rest of the galaxy combined. These flares are the screams of the event horizon, and their increasing frequency is a clear sign that the monster's stomach is currently being filled. What is most unsettling for scientists is the realization that the event horizon is not static. As the black hole consumes matter, it grows. Every star it eats, every gas cloud it swallows, increases its mass and expands the radius of its sphere of doom. The 400 million-mile void we see today is larger than it was a million years ago, with the James Webb Space Telescope revealing a sudden increase in the amount of gas being funneled into the core. It is clear that the monster is in the middle of a growth spurt. We are watching the boundary of the abyss move outward, claiming more of the galaxy for the dark. This expansion is a slow-motion invasion of our reality by a singularity that shouldn't exist, yet dominates the heart of our neighbor. As we conclude our study of this terminal boundary, we must recognize that the event horizon is the ultimate sculptor of the Andromeda galaxy. It dictates the orbits of the stars, the temperature of the gas, and the very fate of the system. It is a monument to the power of gravity, a place where the universe has reached its limit and turned inward. The James Webb Space Telescope has given us a seat in the front row for the most terrifying show in the cosmos, the awakening of a giant and the expansion of its dark domain. The anatomy of the event horizon is the anatomy of the end, and we are witnessing it from a distance that, for the first time in history, feels far too close. The mysteries of Andromeda have long been shrouded in optical illusions that have puzzled the greatest minds in astronomy for generations. When the Hubble Space Telescope first captured high-resolution images of the galaxy's center in 1991, it revealed a feature that seemed to defy the very laws of galactic evolution. The nucleus of Andromeda was not a single point of light, but two. These two distinct concentrations of stars, separated by a mere 5 light-years, created a visual enigma that earned the name the double nucleus. For years, the scientific community was divided, with some theorizing that Andromeda was a cosmic scavenger that had recently swallowed a smaller galaxy, whose core was still intact and orbiting the primary center. This was a dramatic and violent explanation that fit the narrative of a predatory galaxy, but it was ultimately a deception. The truth, revealed through decades of study and now confirmed with the chilling precision of the James Webb Space Telescope, is far more complex and tells a story of gravitational mastery that is almost impossible to visualize. To understand the double nucleus deception, one must first look at the labels astronomers gave these two bright spots, P1 and P2. The brighter of the two, P1, sits slightly off-center and appears to be a massive cluster of old reddish stars. P2T, the dimmer of the two in visible light, occupies the true geometric center of the galaxy and coincides with the location of the 140 million solar mass black hole. If Andromeda were a typical galaxy, P2 should be the undisputed king of the core, yet to the human eye in traditional telescopes, P1 appeared more dominant. This led to the initial belief that P1 was the heart of a victim galaxy. However, researchers eventually discovered that these are not two separate objects. Instead, we are seeing two sides of the same coin, or more accurately, 2 points on a single elongated path. The double nucleus is actually a massive eccentric ring of stars orbiting the black hole in a highly stretched out ellipse. Imagine a racetrack shaped like a long, thin oval. Now imagine a fleet of cars racing around this track. As the cars enter the sharpest turn at one end of the oval, they naturally slow down and bunch together. From a bird's eye view, you would see a high density of vehicles at that specific curve, making it look like a distinct cluster. This is exactly what is happening in the heart of Andromeda. The stars in the central ring are not moving in neat, peaceful circles. Their orbits incredibly elongated, carrying them far away from the black hole before whipping them back toward it. The bright spot known as P1 is simply the epicenter of this ring, the point farthest from the black hole where the stars slow down and linger, creating a concentration of light. The second nucleus, P2, is where the stars reach their maximum speed as they pass the black hole. We are witnessing a gravitational traffic jam of stellar proportions, a structure held together by the sheer invisible will of the monster at the center. The question that has haunted scientists is why these stars would orbit in such a bizarre, unstable pattern. Orbits like these should, over time, settle into circles due to the friction of gas and the gravitational tugging of other stars. The fact that the ring remains so eccentric suggests that a massive, violent event recently disturbed the core. The leading theory is that the 140 million solar mass black hole we see today is the result of a merger between two smaller, yet still massive black holes. When two such entities spiral together and collide, they release a burst of gravitational waves so powerful that the merged black hole can be kicked or recoiled in one direction. This sudden shift in the center of gravity would have acted like a whip, flinging the surrounding stars into the chaotic, elongated orbits we see today. The double nucleus is not a sign of a galaxy being eaten. It is a scar from a time when the black hole itself was reborn through collision. The James Webb Space Telescope has added a new layer of complexity to this deception by observing the nucleus in the ultraviolet and mid-infrared spectrums. While P1 is brighter in the red wavelengths of old stars, P2, the true center, is home to a cluster of hot blue stars that emit fierce ultraviolet radiation. These young stars are a mystery in themselves, in such a high-gravity, high-radiation environment so close to a supermassive black hole. Star formation should be impossible. The tidal forces should tear apart the gas clouds before they can ever collapse into suns. Yet, there they are, a disk of blue stars orbiting the event horizon like a crown of thorns. Webb's sensors have shown that these stars are relatively young, only a few 100 million years old. This suggests that the black hole's awakening is not just a recent event, but part of a cycle of feeding and creation that has been repeating for eons. This deception serves as a reminder that the universe is often more than what it appears to be. The double nucleus was a riddle that forced us to develop better instruments and better mathematics to solve. It taught us that the gravity of a supermassive black hole can act as a lens, distorting our view of the stars and creating illusions of symmetry where there is only chaos. The James Webb Space Telescope has confirmed the eccentric ring is currently being fed by new gas flows. As this gas enters the ring, it collides with the stars already there, creating a turbulent environment that Webb sees as a glowing infrared haze. The jam at P1 is becoming denser, and the light from P2 is becoming more energetic. The deception is falling away, revealing a core that is far more unstable than we ever dared to imagine. For the researchers at the Whispering Scientist, the study of this double nucleus is a study in the power of gravity to rewrite the laws of light. We are looking at a system that has been pushed to the edge of its physical limits. The stars in the ring are traveling at thousands of miles per second, yet they are trapped in an eternal loop by the monster. They surround. They are the heralds of the black hole's power, their very arrangement a testament to the violence of the past. As we watch this structure through the golden mirrors of Webb, we realize that the two nuclei are merely shadows of a single dark truth. The center of Andromeda is a place of singular focus, where everything, light, time, and stars, is being bent toward a final, inevitable point. The truly terrifying part of the double nucleus is what it tells us about the future of our own galaxy. When the Milky Way and Andromeda eventually merge, our own central black hole will be tossed into this eccentric ring. The orbits of our stars will be scrambled, and the peaceful circular rotation of our galactic core will be replaced by the same chaotic, elongated patterns we see in Andromeda. The double nucleus is a preview of the Milkdromeda core, a place of distorted light and bunched-up stars where the gravity of two merged monsters will rule over a broken kingdom. The deception is over, and the clarity we have gained is both a scientific triumph and a cosmic warning. We are seeing the architecture of a post-collision world, a skeleton of stars that has been twisted by the ultimate force of the universe. As we conclude this chapter of the Andromeda mystery, we must accept that the double nucleus is the signature of a survivor. Andromeda has endured mergers and black hole collisions that would have torn lesser galaxies apart. It bears its scars with a terrifying beauty, and through the eyes of Webb, we are finally learning to read them correctly. The smudge in sky has a heart of fire and shadow, and the two lights we once saw were merely reflections of a power that is now fully waking up. The monster is no longer hiding behind a double mask. It is showing its true face, and its influence is reaching out further every day. Galaxies are not peaceful sanctuaries of light. They are the ultimate battlefields of the cosmos, where gravity reigns as a ruthal. SS Tyrant and the large inevitably devour the small. The Andromeda galaxy is a testament to this primordial violence, a serial killer of the stars that has been feeding on its neighbors for over 10 billion years. When we look at its elegant spiral arms through a telescope, we are not just seeing a majestic structure, we are looking at a masterfully hidden graveyard. The history of Andromeda is a history of galactic cannibalism, a long and bloody chronicle written in the shredded remains of the hundreds of smaller galaxies it has lured into its gravitational web. The evidence is not found in the bright central disk, but in the sprawling, ghostly outskirts known as the stellar halo. Here, in the dim reaches of the galaxy's outer envelope, the James Webb Space Telescope and its predecessors have discovered the ghosts of the victims, long, thin streams of stars that were once independent galaxies before they were torn apart and absorbed into the monster's mass. To understand the scale of this cannibalism, one must visualize the process of a merger. When a small dwarf galaxy wanders too close to a giant like Andromeda, it doesn't collide in the way two solid objects might. Instead, it begins a slow, agonizing descent. The tidal forces of the larger galaxy act like invisible fingers, reaching out and pulling on the nearer side of the victim more strongly than the far side. Over millions of years, the dwarf galaxy is stretched and elongated into a stellar stream, a ribbon of stars and gas that can span hundreds of thousands of light years. Eventually, the victim loses its shape entirely, its individual stars becoming permanent residents of the host galaxy's halo. Astronomers using the Hubble and Webb telescopes have mapped dozens of these streams in Andromeda, uncovering a complex web of galactic fossils. By analyzing the ages and chemical compositions of these stars, they have reconstructed a timeline of destruction that suggests Andromeda has consumed between 100 and 200 smaller galaxies during its lifetime. One of the most significant events in this history occurred roughly 2 billion years ago, a relatively recent date in cosmic terms. Andromeda collided with a substantial galaxy, perhaps 1/5 the size of our own Milky Way. This was not a minor snack, it was a feast. The impact triggered massive bursts of star formation across Andromeda disk, lighting up the galaxy with a surge of newborn suns. The remains of this massive victim are still visible today as the giant stellar stream, a gargantuan trail of stars that extends far into intergalactic space. The stars in this stream are metal-rich, meaning they were born in a large, evolved galaxy that had already gone through many generations of stellar birth and death. This is smoking gun of galactic cannibalism. Small dwarf galaxies don't have the resources to produce such stars. The presence of these metal-rich stars in the outer halo proves that Andromeda didn't just grow by slowly accumulating gas, it grew by violently annexing its peers. The James Webb Space Telescope has added a new, more detailed chapter to this history by focusing on the chemical fingerprints of these stolen stars. Because every galaxy has a unique chemical signature based on its star formation rate and history of supernova explosions, Webb can act as a cosmic forensic scientist. It can pick out a single star in Andromeda's halo and determine exactly which consumed galaxy it originally belonged to. This process, known as galactic archaeology, has revealed that Andromeda is currently in the middle of a feeding frenzy. Several dwarf galaxies are currently being shredded. They are the doomed satellites like Messier 32 and Messier 110, which are already showing the physical signs of tidal trauma. Messier 32, in particular, looks like a stripped core, the dense, compact heart of a much larger spiral galaxy that Andromeda has already peeled like a piece of fruit, leaving only he pit behind. This history of cannibalism is not just a fascinating look at the past, it is a terrifying preview of our own future. The Milky Way is also a cannibal, currently consuming the dwarf galaxy Sagittarius, but we are amateurs compared to our neighbor. Andromeda's superior mass and its history of successful conquests make it a formidable predator. Every galaxy it has swallowed has added to its gravitational power, making it a heavyweight that is now coming for us. When the Milky Way and Andromeda eventually collide, it will be the first time in 10 billion years that Andromeda has faced an opponent of similar size. It will be a battle of two cannibals, a mutual destruction that will see both of our home galaxies torn apart, their stars scattered and their identities erased. We will become just another set of stellar streams in the halo of the new, combined galaxy Milkdromeda. The cannibalistic nature of Andromeda also explains why its central black hole is monstrous. Every time a galaxy is consumed, its own central black hole eventually sinks toward the center of Andromeda. These smaller black holes spiral inward and eventually merge with the primary Titan, contributing their mass and energy to the 140 million solar mass beast. The monster we see today is a composite entity built from the hearts of 100 dead galaxies. This is why it is waking up now. The steady influx of gas and stars from its recent cannibalistic meals is finally reaching the event horizon. The ghosts in the halo are not just light and stars, they are the fuel that has powered Andromeda's rise to dominance. What makes this realization terrifying for scientists is the understanding that this process is inevitable and inescapable. Gravity does not have a stop button. The large galaxies in the universe today are all survivors of this brutal cycle of consumption. By studying the scars on Andromeda, we are learning the rules of a game that we are about to play ourselves. The James Webb Space Telescope has revealed that the halo of Andromeda is much larger and more packed with debris than we previously imagined. It is a vast, invisible net that stretches out for 1,000,000 light-years, already beginning to overlap with our own. We are already entering the hunting grounds. The history of galactic cannibalism tells us that Andromeda does not just pass by, it absorbs. As we stand on the edge of this realization, the beauty of the night sky takes on a darker tone. The Andromeda galaxy is a monument to billions of years of cosmic theft. Every star in its halo is a displaced refugee, a remnant of a world that no longer exists. Through the eyes of Webb, we see the true face of our neighbor, a titan built from the ruins of others, moving silently through the dark tour. Its next great meal. Cannibalism is no accident, it is the law of the universe. Andromeda has refined this process into an art form, and we are the next canvas. The ghosts are watching, and they know exactly what it feels like to fall into the giant's gravity. To truly understand the narrative of a galaxy as ancient and vast as Andromeda, one must look away from the blinding brilliance of its company. And venture into the ghostly, diffuse outer reaches known as the stellar halo. This is the realm of galactic archaeology, a place where time seems to stretch and thin, preserved in the motions of stars that haven't visited the galactic center for billions of years. The halo is not a mere border, it is a sprawling, nearly invisible sphere of old stars and dark matter that extends hundreds of sands of light years into the intergalactic void. Within this vast volume, the James Webb Space Telescope has begun to detect echoes, vibrations of past collisions, and the chemical whispers of civilizations that may have vanished before our sun was even a glimmer in a molecular cloud. These archaeological echoes are the only remaining proof of the galaxies Andromeda has already conquered, and they provide a chilling context for the trajectory our own Milky Way is currently following. If you were to strip away the bright spiral disk of Andromeda, you would be left with this halo, a cloud of stellar debris that tells a story of relentless expansion. Astronomers using the precision of the Webb telescope have discovered that this halo is not a uniform mist of stars, but a complex tapestry of for densities and streams. Imagine tearing apart a great city, brick by brick, and scattering the rubble across 1,000 miles of desert. Millions of years later, a diligent detective could still reconstruct the city's original layout by analyzing the patterns and chemical composition of the scattered stones. That is exactly what galactic archaeologists are doing. They have identified distinct streams of stars that move with a shared momentum, like the ghosts of soldiers still marching in formation long after their war has ended. These stars do not belong to Andromeda's native population. They are the stolen property of 100 smaller dwarf galaxies that were lured into the giant's trap. The Webb telescope's ability to resolve individual red giant stars in these distant reaches has changed the game of cosmic forensics. By measuring the metallicity of these stars, the ratio of heavy elements like iron and magnesium to hydrogen, scientists can determine the exact environment in which they were born. Stars born in small isolated dwarf galaxies are chemically primitive, lacking the heavy elements forged in the rapid succession of supernovas found in larger galaxies. When Webb finds a cluster of chemically primitive stars moving through the outer halo of Andromeda, it is looking at a fossilized remnant of a dead world. These stars are archaeological echoes of a specific merger event. Some of these echoes are relatively fresh, dating back only a few 100 million years, while others are ancient, dating back to the very first eras of the universe. The halo is essentially a library of death, where every shelf contains the records of a different galactic victim. One of the most unsettling discoveries in this archaeological survey is the inner halo of Andromeda, which contains a surprising number of metal-rich stars. This shouldn't be possible in a standard model of galactic growth. The outer regions of a galaxy should be populated by the oldest, simplest stars. Ending complex, metal-heavy stars so far from the center suggests that Andromeda underwent a massive, transformative collision roughly 2 to 4 billion years ago. A collision so violent that it physically displaced millions of stars from its inner disk and flung them into the outskirts. This is evidence of a galaxy that has been repeatedly broken and rebuilt. The echoes of this specific collision are still visible as shells of gas and stars that wrap around the galaxy like the layers of an onion. Webb's infrared vision has mapped these shells in unprecedented detail, revealing that they are still vibrating from the impact. Archaeological study of the halo also reveals the invisible hand of dark matter. While the stars provide the light, they are merely tracers for a much larger, darker structure. Andromeda's dark matter halo is a monstrous entity, stretching perhaps 1 million light-years in every direction and exerting a gravitational influence that reaches out to touch our own. By tracking the archaeological echoes, the way the stellar streams curve and accelerate, scientists can see the shape of the dark matter that is pulling them. They have found that Andromeda's dark matter is not a smooth, perfect sphere, but is lumpy and distorted, filled with subhalos that are likely the remains of dark matter clouds that accompany the consumed galaxies. This tells us that cannibalism isn't just happening to the stars, it's happening to the very fabric of the dark universe. The terrifying aspect of these archaeological echoes is the realization of the scale of destruction. We are not just looking at a few lost stars, we are looking at the remnants of entire systems of planets, and perhaps the history of life itself. Every stream in the halo represents a potential 1 trillion planets that have been ripped away from their home suns and cast into the darkness. When a galaxy is shredded by Andromeda's tidal forces, the planetary systems within it are subjected to extreme gravitational stress. Orbits are destabilized, planets are flung into the void, and moons are torn from their hosts. The echoes we hear through our telescopes are the final, dying notes of these solar systems. We are witnessing the aftermath of a cosmic apocalypse that has repeated itself hundreds of times in our neighbor's history. As we look toward our own future, these archaeological echoes serve as a map of what will eventually happen to the Milky Way. Our own stars will one day be the overdensities in the new galaxy's halo. Our sun will be one of those red giants that a future version of Webb will analyze for its chemical signature. We will become a stream of stars, a ghostly ribbon of light circling the central monster. The archaeological evidence shows that there is no escape once you enter the halo, you are part of the record. The history of Andromeda is written in the displaced and the destroyed, and the echoes are getting louder as we get closer. The James Webb Space Telescope continues to sift through this stellar rubble, finding new streams and identifying new victims every day. Each discovery reinforces the image of Andromeda as a titan of accumulation, a galaxy that is more the sum of its parts than a singular entity. The halo is a place of quiet, haunting beauty, but it is also a place of ultimate loss. It is the galaxy's memory, a repository for everything it has taken from the universe. As we listen to these echoes, we are forced to confront the reality that we are the next chapter in this archaeological record. The whispering scientist reminds us that the stars do not just shine, they remember. And what they remember about Andromeda is a story of hunger that never ends. Orbiting the Andromeda galaxy like a swarm of ancient glowing bees is a population of objects that are among the oldest and most mysterious in the known universe, globular clusters. These are not mere clusters of stars, they are dense, spherical cities of light, each containing hundreds of thousands, sometimes millions of suns packed into a space only a few dozen light-years across. If you lived on a planet inside one of these clusters, your night sky would never be dark. Instead of a few thousand distant points of light, you would be surrounded by tens of thousands of stars as bright as the full moon, crowding the heavens in a display of celestial brilliance that would make the concept of night entirely foreign. The James Webb Space Telescope has turned its gaze upon this swarm, revealing that these globular clusters are not just beautiful relics of the early cosmos, but the silent, durable witnesses to every act of violence Andromeda has ever committed. In our own Milky Way, we host a modest collection of about 150 globular clusters. They are the elders of our galaxy, residing in the halo and avoiding the chaotic gas-filled disk. But Andromeda is a different kind of monster. It hosts a swarm of over 400 confirmed clusters, with many more likely hidden in the glare of its core or the deep shadows of its outer reaches. This discrepancy is one of the most significant clues to Andromeda's predatory nature. In the mathematics of T universe, the number of globular clusters a galaxy possesses is a direct reflection of its merger history. Each time Andromeda consumed a dwarf galaxy, it didn't just take its stars and its gas, it inherited its globular clusters. These clusters are incredibly resilient, held together by such intense mutual gravity that they can survive the shredding of their parent galaxy and emerge intact, becoming adopted children of the giant that destroyed their home. The James Webb Space Telescope has allowed astronomers to perform an unprecedented census of this swarm. By peering into the dense, crowded hearts of these clusters using infrared light, Webb can resolve individual stars that were previously a blurry mess of light. What it found was a population split into two distinct groups, 1G, group orbits in a relatively flat plane, moving in synchronization with the rotation of Andromeda's main disk. These are the natives, born over 12 billion years ago, when the galaxy first began to coalesce from the primordial mist of the Big Bang. But the second group, the invaders, moves on wildly inclined orbits, some even traveling in the opposite direction of the galaxy's spin. These are stolen clusters, the gravitational trophies taken from the dozens of galaxies Andromeda has devoured. Through the lens of Webb, we are seeing the immigrant population of the galaxy, and their presence tells a story of constant repeating conquest. Perhaps the most famous member of this swarm is a cluster designated B23G78, often called Male 2 or G1. It is the single most massive globular cluster in the local group, containing several million stars and weighing more than some entire dwarf galaxies. It is so massive and so dense that many scientists believe it is not a true globular cluster at all, but the stripped core of a massive galaxy that Andromeda destroyed eons ago. All that remains of that once great spiral is this dense, spherical heart, a lonely monument orbiting the predator that killed it. Webb's spectroscopic analysis of G1 has revealed that it may even harbor an intermediate mass black hole at its center, a missing link in the evolution of black holes that provides a terrifying glimpse into how the monster at the heart of Andromeda may have started its own journey. The swarm also acts as a set of gravitational sensors for the entire galaxy. Because these stars are scattered throughout the vast volume of Andromeda's halo, their motions can be used to map the invisible distribution of dark matter. Like buoys bobbing in an invisible ocean, the way these clusters accelerate and decelerate tells us where the hidden mass of the galaxy is located. The James Webb Space Telescope has tracked these bees with such precision that it has revealed a startling truth. Some of the clusters are moving far faster than they should be. They are being tugged by something we cannot see, likely the incoming gravitational influence of the Milky Way's own dark matter halo. The swarm is already agitated. The bees are the first to feel the change in the cosmic weather, and their erratic orbits are a clear sign that the two largest galaxies in the local group are beginning to interfere with each other's internal dynamics. What is truly unsettling about these clusters is their age. Most stars are as old as the universe itself. They were born in a time before the first heavy elements were forged in the hearts of later suns. They are metal-poor relics, composed almost entirely of hydrogen and helium. These stars have watched the entire history of the local group unfold. They were there when the first galaxies formed. They watched as Andromeda ate its neighbors, and they are here now as it prepares for its final meeting with us. They are the ultimate survivors. When the Milky Way and Andromeda collide, the stars in the disks will be flung into new chaotic orbits, and many will be ejected into the void. But the globular clusters will likely endure. The Y will pass through the crashing gas clouds like cannonballs, their internal gravity keeping their millions of stars bound together, even as the world around them is torn asunder. As we listen to the whispering of these ancient clusters through our telescopes, we are forced to recognize that we are looking at the ultimate fate of our own home. Our own 150 globular clusters will soon join this swarm. They will become part of the collective, swirling around the new Andromeda center alongside the hundreds of others that Andromeda has already collected. The swarm is growing, and its buzzing is the sound of billions of years of accumulation. The James Webb Space Telescope has shown us that there is no part of Andromeda that is truly at rest. Even these ancient stable cities of stars are caught in the grip of the coming transition. They are markers of the past and heralds of the future, orbiting in the darkness like the gravestones of dead galaxies. The data provided by Webb has also shown that some of these clusters are currently undergoing tidal stripping. Even as they orbit, the massive gravity of Andromeda is slowly peeling stars away from their outer EG, creating thin tails of starlight that trail behind the clusters. It is a reminder that in the presence of a giant, nothing is truly safe. Even the most tightly bound structures in the universe are eventually subjected to the will of the 140 million solar mass monster and its trillion-star furnace. The swarm of ancient B clusters is a beautiful, shimmering spectacle, but it is also a tally of the fallen. It is the record of everyone who came before us and was consumed by the neighbor that is now knocking at our door. Through the eyes of Webb, we see the swarm for what it is, a collection of cosmic memories, waiting for the next one to be added. Andromeda does not travel the intergalactic highways alone. Like a dark monarch of the void, it is accompanied by a tragic entourage of light galaxies, a collection of smaller systems that are currently trapped in a gravitational death spiral. These satellites, primarily known by their designations in the Messier catalogue, are the living proof of Andromeda's insatiable hunger and the eventual fate that awaits any object that wanders too close to its borders. The James Webb Space Telescope has turned its high-resolution infrared soars toward these companions, revealing that they are far more than just distant neighbors. They are victims in various stages of a long, agonizing digestion. The two most prominent members of this doomed entourage, Messier 32 and Messier 110, provide a stark visual contrast in how a giant treats the weak. While one has been stripped to its very core, the other is being slowly squeezed, its internal gas pressurized into a final, desperate burst of star formation before the light goes out forever. Messier 32 is perhaps the most unsettling member of the group. To the naked eye, it appears as a small, compact blur of light nestled close to the main spiral of Andromeda, but the infrared data from Webb has revealed a much more violent reality. Messier 32 is a compact elliptical galaxy, a rare E-type of system that is unnervingly dense for its size. Scientists now believe that M32 was once a majestic spiral galaxy, similar in size and beauty to our own Milky Way. However, over billions of years, it committed the fatal error of orbiting too close to Andromeda's disk. Each time it passed through the gravitational field of the giant, its outer stars, its graceful spiral arms, and its life-giving gas were peeled away, like layers of skin being stripped from a bone. What we see today is merely the pit of that original galaxy, the dense central bulge that was too tightly bound by gravity to be fully torn apart. It is a skeletal remnant, a ghost of a galaxy that has been reduced to a fraction of its former self, orbiting its tormentor in a state of permanent ruin. On the other side of Andromeda sits Messier 110, a dwarf elliptical galaxy that appears, at first glance, to be more intact. It is farther away from the central black hole, sitting at a distance of roughly 190,000 light-years, but it is no less doomed. Webb's mid-infrared instrument has detected something unusual inside M110, pockets of young, blue stars and dust. This is highly irregular for an elliptical galaxy. CH are typically red and dead systems filled only with ancient, aging suns. The presence of these newborn stars is a sign of gravitational compression. As Andromeda's massive gravity pulls on M110, it creates tidal shocks that slam into the smaller galaxy's remaining gas clouds. These clouds are squeezed until they collapse, igniting a final generation of stars. It is a beautiful, shimmering spectacle, but it is the light of a terminal patient. Andromeda is essentially wringing the last bits of life out of M110, forcing it to consume its remaining fuel before it is eventually shredded and absorbed into the stellar halo. Beyond these two famous satellites, Webb has uncovered a much larger, invisible entourage. There are at least 14 confirmed dwarf galaxies orbiting Andromeda Ma. 9 of them so faint and dominated by dark matter that they were invisible to previous generations of telescopes. These ultra-faint dwarfs are the ultimate cosmic orphans. They consist of only a few thousand stars, yet they are encased in massive cocoons of dark matter that outweigh their visible light by a factor of hundreds. What Webb has discovered is that these satellites do not orbit in a rand, spherical cloud as standard physics would suggest. Instead, they move in a coherent, thin rotating plane known as the Great Plane of Andromeda. This structure is a scientific enigma that defies our current understanding of how galaxies form. It suggests that these satellites were not captured individually over time, but were part of a larger stream of matter, a cosmic highway that Andromeda 1 intercepted and is now methodically dismantling. The doomed nature of this entourage is confirmed by the discovery of tidal tails extending from several of these satellite galaxies. These are long, thin ribbons of stars that have been pulled out of the satellites and are now trailing behind them like a wake behind a ship. Webb's sensitivity to low-surface brightness objects has allowed us to see these tails in exquisite detail, mapping the flow of stars from the victims into the predator. We are witnessing a slow-motion mass transfer. Every second, stars that were once called M32 or M110 home are being transferred to the ledger of Andromeda. The entourage is essentially a waiting room for the stellar halo. Eventually, every one of these galaxies will lose its identity entirely, and EA stars will join the archaeological echoes we discussed in previous chapters. For the researchers at the Whispering Scientist, the study of these satellites is a study in the physics of the inevitable. There is no force in the universe that can push these galaxies back into the safety of the void. Once they were caught in Andromeda's gravitational well, their fate was sealed. The same principle applies to our own satellite galaxies, like the large and small Magellanic Clouds. They are our entourage, and they will share our fate. When the Milky Way and Andromeda collide, these two groups of satellites will be thrown into a chaotic three-body dance. Some will be flung into the intergalactic void, becoming lonely rogue galaxies, drifting in the dark. But most will be swallowed by merged Titan. The entourage is a preview of the scale of the coming disruption. It shows us that in the presence of such massive gravity, even an entire galaxy can be treated as a minor snack. The infrared eyes of Webb have also revealed that the space between Andromeda and its satellites is not empty. It is filled with a thin glowing mist of intra-halo light, stars that have already been stripped from the satellites but haven't yet settled into their final orbits. This mist acts as a gravitational map, showing us exactly how the entourage is being dismantled. It is a hauntingly beautiful sight, a graveyard of light that connects the predator to its prey. As we watch M32 and M110, we are watching the final moments of objects that have existed for over 10 billion years. They have survived the early turbulence of the universe, only to meet their end at the hands of their closest neighbor. The terrifying part of this observation is the realization that the entourage is not just a collection of stars, but a collection of potential worlds. How many planets within M32 were once habitable before their home galaxy was stripped of its gas and its structure? How many civilizations might have looked up at the looming disk of Andromeda with the same dread we feel today? The doomed entourage of Messier is a reminder that the universe is a place of constant forced transition. Nothing remains independent forever. Gravity is a collector, and Andromeda is the most efficient collector in our part of the cosmos. As we finish our census of these satellites, we realize that we looking at a mirror. We are the next entourage, the next group to be drawn into the dance, and the mirrors of Webb are showing us exactly how the dance ends. For decades, the collision between the Milky Way and Andromeda was described as a distant, theoretical catastrophe, a cosmic event relegated to a future so remote it felt like a fairy tale. Scientists spoke of 4 billion years as a safety buffer, a vast temporal moat protecting our solar system from the violence of the giant. But that comfort was shattered by a discovery that has fundamentally shifted our perspective on our place in the local group. Through the meticulous mapping of ionized gas, researchers have confirmed a startling reality: the collision has already begun. We are no longer waiting for the first contact, we are living through it. The two galaxies have already touched, not with their bright stellar disks, but with their invisible gargantuan halos. These enormous envelopes of hot, thin plasma reach out over 1 million light-years in every direction. And as we drift through the dark, the outer edges of our home are currently brushing against the outer reaches of Andromeda. This discovery came through a project CT known as Omega, the absorption map of ionized gas in Andromeda. By using the Hubble Space Telescope to observe the light of distant quasars as it passed through the space surrounding Andromeda, astronomers were able to detect the subtle chemical fingerprints of its halo. What they found was a structure of staggering proportions. Andromeda's halo is not a small cloud, it is a sprawling, multi-layered atmosphere of gas that extends far beyond the visible stars we see in the night sky. The Milky Way has a similar massive halo, because the distance between our two galaxies is roughly 2.5 million light-years, and both halos extend at least 1 million light-years from their respective centers. The math is inescapable. The boundaries have overlapped. These two cosmic islands are already communicating through the medium of hot, ionized gas, exchanging the first whispers of a merger that will eventually melt them both down. The halo touch is the first stage of the galactic merger, a period of silent interaction that precedes the visual spectacle of colliding stars. While the gas in these halos is incredibly thin, barely a few atoms per cubic meter, the volume is so vast that the halos contain enough mass to fuel the birth of billions of new stars. As the two halos interpenetrate, the gas atoms collide at hundreds of miles per second, creating a subtle pressure and heat that ripples through the interstellar medium. This is the terrifying part of the data. The interaction is already influencing the galactic weather of both systems. We are currently passing through a region of space that is being shaped by Andromeda's gravity and its thermal energy. The invisible collision is happening above us, beneath us, and all around us, even as we sit in the supposed safety of our spiral arms. The James Webb Space Telescope has provided the necessary infrared detail to see how this halo interaction is affecting the denser gas within the galaxies. While the outer halos are thin and hot, the inner regions are thick with dust and molecular clouds. Webb has detected bow shocks and unusual turbulence at the edges of Andromeda's disk that suggest it is experiencing drag as it pushes through the intergalactic medium and our own overlapping halo. This drag is a subtle break, slowing the galaxies down and ensuring they fall even more deeply into each other's gravitation. Al embrace. It is the beginning of the end of independence. For billions of years, the Milky Way and Andromeda were separate entities, two lonely travelers in the dark. Now they are a single bound system, locked in a kinetic embrace that will only tighten as the eons pass. To understand the scale of the halo, one must imagine the night sky not as a black void with scattered points of light, but as a dense, glowing fog of plasma. If our eyes could see the ionized gas of the Andromeda halo, the galaxy would not be a small smudge in Cassiopeia. It would appear as a massive glowing cloud spanning nearly 100 times the width of the full moon. It would dominate the heavens, a celestial ceiling of light that would make every other star seem like a mere spark in a great bonfire. This is the reality we are currently inhabiting. We are inside the cloud, The whispering scientist reminds us that we often mistake the limits of our vision for the limits of reality. Just because we cannot see the halo with our naked eye does not mean we aren't currently being affected by its presence. The implications for our star's future are profound. As the halos continue to merge and compress, the gas within them will begin to cool and fall toward the centers of the galaxies. This influx of fresh fuel could trigger a new era of star formation in both the Milky Way and Andromeda, a final baby boom of suns before the violent disruption of the stellar disks. However, this compression also feeds the central black holes. The X-ray flares and neutrino bursts we have discussed are likely being stoked by the changing pressure of the overlapping halos. The monster at the heart of Andromeda is waking up because it can feel the touch of the Milky Way. The gravitational tides are rising and the water is beginning to churn. This collision stage is deceptively peaceful. To an observer on Earth, nothing seems to have changed. The seasons come and go, the constellations remain in their familiar patterns, and the sun rises as it always has. But on the scale of cosmic time, we are at the moment of impact. The first molecules of our two worlds have met. Over the next 2 billion years, the interaction will shift from invisible gas to visible stars. The halos will act as a lubricant, drawing the galaxies together with increasing speed until the first close pass occurs. During that pass, the night sky will change forever. Andromeda will swell in size, its spiral arms stretching across 40 degrees of the sky, a magnificent and terrifying sight that will mark the end of our isolation. But now we live in the halo touch era. It is a time of quiet realization, a moment when our scientific instruments have revealed that we are part of something much larger and more violent than we ever suspected. The collision is not a future event for our descendants to worry about. It is a current reality for us to study and respect. We are already being integrated into Andromeda's structure. The atoms of our halo and theirs are mixing, creating a new, shared environment that will eventually become the atmosphere of Milkdromeda. The James Webb Space Telescope continues to map these overlap zones, showing us the turbulent front lines of the merger. What we see is the real meaning of a galactic neighborhood. A neighborhood is not just a collection of separate houses, it is a shared space where the actions of one affect the others. By touching our halo, Andromeda has made its presence felt in a way that is both intimate and overwhelming. It is a reminder that in the universe nothing is truly isolated. Gravity is a bridge and gas is a messenger. The messages currently being sent from Andromeda's halo are full of energy and change. We are no longer bystanders in the story of the local group. We are the protagonists in the opening chapter of its greatest transformation. The collision has begun, and the invisible touch of the giant is the first step toward a destiny we can no longer avoid. While the cosmic drama of Andromeda unfolds over millions of light-years, its ultimate impact will be felt most acutely on the small, fragile rock we call home. We often speak of the galactic collision as the end of our story, but the truth revealed by modern astrophysics is far more complex and ironically tragic. Long before the first stars of Andromeda mingle with the stars of the Milky Way, the Earth will have already met its fiery end, not at the hands of a distant galaxy, but by the very sun that gave it life. To understand the burning of the home world, one must look at the clock of stellar evolution. Our star is a middle-aged yellow dwarf, currently stable and reliable, but it is not a static object. It is a nuclear furnace that is gradually, inevitably growing hotter. As hydrogen fuses into helium within its core, the resulting helium ash increases the core's density and temperature. This makes fusion reactions run faster, releasing more energy every billion years. By the time the Andromeda galaxy dominates our sky, the sun will be 40% brighter than it is today, and the Earth will be a scorched, lifeless husk. The timeline for this terrestrial apocalypse is surprisingly short in cosmic terms. In roughly 1 billion years, a mere fraction of the time remaining before the galaxies fully merge, The sun's increasing luminosity will trigger a runaway greenhouse effect on Earth. As the surface temperature rises, the vast oceans that define our blue planet will begin to evaporate. Water vapor is a potent greenhouse gas, and its presence in the atmosphere here will trap even more heat, leading to further evaporation in a feedback loop that cannot be broken. The blue marble will fade into a dusty ochre sphere. The lush forests, the teeming cities, and the very air we breathe will be stripped away by the unrelenting solar wind. Within a few 100 million years of this process beginning, Earth will resemble a twin of Venus, a hellish world where our face temperatures are hot enough to melt lead, and the pressure of the thick, acidic atmosphere is crushing. This realization provides a haunting context for the James Webb Space Telescope's observations of Andromeda. We are looking at a future that we will never witness from the surface of our own planet. The terrifying beauty of the approaching galaxy is a show for an empty theater. By the two galactic disks interpenetrate. Humanity's cradle will have been sterilized. If our descendants still exist, they will have long since migrated to the outer reaches of the solar system, perhaps to the moons of Jupiter or Saturn, or perhaps they will have left the sun behind entirely to find refuge around a younger, cooler star. The burning of the home world is a reminder of the fleeting end, a chore of habitability. Life exists in a narrow window of time and space, a fragile equilibrium that is constantly being encroached upon by the march of stellar physics. As the sun expands, the habitable zone, the region where liquid water can exist, will move outward. While Earth burns, the frozen wastes of Mars may briefly thaw, and the icy crusts of Europa and Enceladus may melt into vast global oceans. But even this reprieve is temporary. The sun is a ticking time bomb, and its eventual transition into a red giant will likely see it expand to the point where it swallows Mercury, Venus, and possibly the Earth itself. The atoms that make up our bodies, our buildings, and our history will be returned to the stellar furnace from which they were originally forged. This is the internal collie that precedes the external one. Before we are absorbed by Andromeda, we must survive the transformation of our own star. The James Webb Space Telescope has captured images of planetary nebulae and dying stars in Andromeda that serve as a mirror for our own solar system's fate. We see zombie planets orbiting white dwarfs, and we see the chemical debris of shattered worlds being inhaled by heir-parent suns. These observations confirm that the burning we anticipate for Earth is a common occurrence in the life cycle of a galaxy. The trillion-star furnace of Andromeda is filled with the charred remains of worlds that were once as vibrant as ours. Every star we see in the night sky is a potential engine of destruction for the planets orbiting it. The universe does not preserve its creations, it recycles them. However, there is a strange, cold comfort in the timing of these events. If Earth were to survive the sun's expansion, the galactic collision itself would be far more disruptive to our environment. As the two galaxies merge, the gas clouds of the Milky Way and Andromeda will slam together, triggering immense bursts of star formation. These starbursts will fill the sky. Massive, short-lived blue stars that will end their lives in spectacular supernova explosions. If Earth were still habitable during this era, the frequent supernovas in our galactic neighborhood would bathe the planet in lethal doses of cosmic radiation, stripping away the ozone layer and causing mass extinctions. By burning early, the Earth is spared the chaotic radiation-heavy death of the galactic merger. We are a quiet world meeting a quiet end before the storm arrives. The whispering scientist observes that the burning of the home world is the ultimate act of cosmic housekeeping. To make room for the new, massive galaxy of Andromeda, the old structures must be cleared away. The Earth, the Sun, and the familiar constellations are the scaffolding of a previous era. As we watch Andromeda's black hole wake up and its stars accelerate toward us, we are seeing the beginning of the new construction. The heat that will destroy our world is the same energy that fuels the evolution of the cosmos. We are part of a grand thermal cycle, a transition from the complexity of life to the simplicity of pure energy. As we look out at the golden mirrors of Webb, we are searching for meaning in a universe that is fundamentally indifferent to our survival. The burning of our world is a certainty, a mathematical result of how stars work, but the fact that we can predict it, that we can measure the increasing heat of our sun and the increasing speed of Andromeda, is a testament to the power of the human mind. We may be temporary specks on a doomed planet, but we have reached out and touched the stars with our intellect. We have understood the mechanics of our own destruction, and in that understanding we have achieved a kind of immortality. The home world will burn, its oceans will boil, and its mountains will melt. But the story we have uncovered will remain written in the light of the stars. The final realization of this chapter is that home is a moving target. If we are to survive the burning of the earth, we must learn to call the stars themselves our home. We must become a species of the galaxy, not just a single world. Andromeda is coming, and our sun is growing, and between these two titans, there is no place for a stationary civilization. We must move, or we must fade. The mirrors of Webb are showing us the path forward, revealing the habitable zones of distant ant suns and the chemistry of new worlds. The fire is coming, but we have the tools to see it, and for the first time in history, we have the chance to outrun it. In the distant future, 7 billion years from now, the night sky will bear no resemblance to the star-scattered velvet we see today. The familiar constellations, the hunters, the bears, and the swans, will have long since dissolved into a chaotic slurry of light as the two greatest titans of the local group finally complete their merger. The Milky Way and Andromeda will no longer exist as separate entities. They will have fused into a singular, colossal structure known to astronomers as Milkdromeda. This new galaxy will be a giant elliptical, a bloated, football-shaped swarm of nearly 2 trillion stars. To any observer left with, in its boundaries, the sky will be a seamless glowing canopy, a thick mist of ancient reddish light that stretches from horizon to horizon. The elegant spiral arms that once defined our home will be gone, replaced by a smooth, featureless glow that marks the final state of galactic evolution. This is the era of Milkdromeda, the ultimate destination of our 4 billion year fall through the dark. The birth of Milkdromeda is not a gentle event, but a spectacular, violent transition that begins with the first close pass of the two galaxies. As their disks interpenetrate, the stars themselves do not collide. The space between them is too vast, like 2 swarms of gnats passing through one another without a single mid-air impact. However, the gas is another story. When the massive hydrogen cloud of the Milky Way slam into the gas reservoirs of Andromeda at millions of miles per hour, they compress with a force that defies imagination. This triggers the final, most intense burst of starbirth in our region of space. Millions of massive blue-white stars will ignite simultaneously, lighting up the merging galaxies with a brilliance that would be visible across the entire observable universe. For a few 100 million years, the sky would be filled with these short-lived, spectacular suns, their fierce light reflecting off the turbulent dust clouds of the merger. But this starburst is a candle burning at both ends. Because the collision is so efficient at compressing gas, it uses up the galaxy's remaining fuel with terrifying speed. Most of the gas that isn't turned into stars is either swallowed by the newly merged supermassive black hole or blown out into intergalactic space by the intense radiation of the newborn suns. Within 1 billion years after the merger completes, Milkdromeda will have exhausted its star-forming potential. It will become a quiescent galaxy, a place where the fires of creation have finally gone out. The blue stars will die in a rapid-fire succession of supernovas, leaving behind only the long-lived, cooler red stars. The sky of Milkdromeda will transition from a vibrant, chaotic blue to a deep, haunting amber. It will be a galaxy of old souls, a retirement home for stars that will burn slowly for trillions of years into the increasing darkness of the expanding universe. The structural transformation is equally profound. Spiral galaxies like our own are defined by order. Their stars move in neat circular orbits within a flat disk. But a merger is a gravitational scrambler. The mutual pull of the two galaxies flings stars into random, eccentric trajectories. By the time the merger is complete, the organized rotation is lost. Stars in Andromeda will move on chaotic orbits that carry them from the far reaches of the halo deep into the heart of the galaxy and back out again. The result is a giant elliptical shape, a three-dimensional cloud of stars that has no up or down. If you were still orbiting the Sun within this new galaxy, the Milky Way's familiar band of light would be gone. Instead, the entire sky would be filled with a uniform, hazy glow of stars, as if you were living inside a giant, glowing lantern. At the center of this new kingdom, the two supermassive black holes will eventually find each other. The 140 million solar mass monster from Andromeda and the 4 million solar mass heart of the Milky Way will spiral inward, drawn by dynamical friction as they plow through the dense central star clusters. Their eventual merger will be the final exclamation point in Andromeda's creation. The collision of these two singularities will release a burst of gravitational waves so powerful that it will physically warp the space-time of the entire galaxy for a few brief moments. This event will likely trigger a final massive flare as the remaining gas in the core is swallowed by the new combined black hole. For a few million years, the center of Andromeda might shine as a quasar, a lighthouse of high-energy radiation that would be lethal to any life nearby, before finally settling into a long dark silence. The James Webb Space Telescope's observations of distant merger remnants give us a preview of this future. We see galaxies that look like twisted wreckage, their stars trailing away in long tidal tails that look like the arms of a ghost. We see the red and dead elliptic ALS that represent the final stage of this process, galaxies that have given up their gas and settled into a stable, featureless old age. Andromeda will be one of these. It will be the largest and most dominant feature of the local group, eventually absorbing every other dwarf galaxy in the neighborhood, including Triangulum and the Magellanic Clouds. Over tens of billions of years, the local grow up will become a one-galaxy universe, as the expansion of space pushes all other galaxy clusters beyond our cosmic horizon. The whispering scientist reflects on the poetic irony of this final state. We spent our entire history looking out at a universe filled with billions of galaxies, each a separate island of light. But the inhabitants of Andromeda, should they exist, will see a very different universe. To them, the sky will be nearly empty, except for the glowing mist of their own massive galaxy. There will be nothing else to see. The expansion of the universe will have moved all other galaxies so far away that their light can no longer reach us. Andromeda will be a lonely island in an infinite dark sea. The sky full of Andromeda is a sky of ultimate unity, but also of ultimate isolation. Everything we ever knew, the Milky Way, Andromeda, and their satellites, will have become one, but it will be all that remains. This future sky is a testament to the inescapable power of gravity. It is the end result of a process that began with the first density fluctuations in the early universe. The merger is the destiny of our local neighborhood, a final consolidation of matter before the heat death of the universe. As we look at Andromeda today, we are seeing the raw materials of this future world. We are seeing the half-finished sculpture that gravity is still carving. The terrified scientists of the present are merely those who have glimpsed the end of the book and realized that the final chapter is one of silence and stasis. But there is also beauty in this finality. Andromeda will be a monumental achievement of the cosmos, a singular, massive structure that represents the combined history of trillions of stars. As we conclude this vision of the merged sky, we realize that the collision we fear is actually a transformation. The death of the Milky Way is the birth of something much larger. We are part of a cycle of destruction and creation that operates a scale we are only just beginning to understand. The golden mirrors of Webb are the tools we use to read the map of this journey. We see the speed, we see the mass, and we see the inevitable destination. The sky of the future is waiting for us, glowing with the amber light of 1 trillion ancient suns, a silent witness to the time when two great galaxies finally found peace in each other's arms. In the grand, chaotic lottery of a galactic merger, the fate of any single star is governed by the cold, impartial laws of probability and gravitational slingshotting. As the Milky Way and Andromeda begin their final, intimate dance, our solar system will find itself caught in a celestial whirlwind that cares nothing for the history of the worlds it carries. While we often imagine the collision as a dense crushing of matter, the reality is that the space between stars is so vast that the impact is more akin to two clouds of smoke drifting through one another. However, while direct stellar collisions are almost statistically impossible, gravitational interactions are guaranteed. Every star that passes near our Sun will exert a tug, a subtle or violent redirection of our path through the DA. For our solar system, the most likely outcome of this merger is not destruction but exile. According to the most advanced supercomputer simulations, there is a significant chance that our Sun will be flung far from its current comfortable home in the suburban disk and cast into the lonely, freezing outskirts of the new galaxy. Currently, our Sun resides in a stable circular orbit, roughly to 26,000 light-years from the center of the Milky Way. We are protected by the thickness of the galactic disk, surrounded by neighbors that move at similar speeds in a predictable rhythmic rotation. This stability has lasted for over 4 billion years, providing the steady environment necessary for life to emerge and evolve. But as the Andromeda Titan approaches, this circular harmony, will be shattered. The tidal forces of the incoming galaxy will act like a cosmic rake, pulling at the stars of our disk and dragging them into eccentric, elongated paths. Our Sun will be subject to a series of gravitational kicks. If we are unlucky enough to pass near a massive star cluster or a dense molecular cloud during the merger, we could be accelerated to incredible speeds. Simulations suggest a 12% probability that the solar system will be ejected from the merged galaxy entirely, becoming an intergalactic nomad. Imagine the perspective of a future inhabitant of our solar system during this era of exile. If we are flung into the intergalactic void, the night sky would undergo a haunting transformation over the course of several million years. At first, the combined light of the merging galaxies would dominate the heavens, a swirling incandescent mess of blue starbirth and red dust. But as our star gains velocity and moves away from the center of mass, that brilliant structure would begin to shrink. It would recede into a single glowing patch of light, eventually becoming nothing more than a faint, fuzzy smudge in a sky of absolute blackness. There would be no other stars in the sky, no constellations, no Milky Way, no neighbors. We would be alone in a vacuum so profound that the nearest sun might be millions of light years away. The solar system would become a lonely island of light, drifting through a sea of infinite nothingness, a true exile from the community of stars. Even if we remain bound to the new galaxy, Andromeda, our new home will be far from the one we know. The most probable scenario is that we will be relocated to the far reaches of the new galactic halo, perhaps 50,000 to 100,000 light-years from the center. In this distant exile, the night sky would be lopsided. One half of the heavens would be dominated by the massive, glowy NG core of the elliptical galaxy, a concentrated ball of 1 trillion ancient suns, while the other half would look out into the empty void. We would no longer be part of a disk, we would be part of a diffuse spherical swarm. The whispering scientist notes that this relocation is the ultimate cosmic displacement. We would go from being citizens of a vibrant, rotating metropolis to being hermits on the edge of a vast, silent desert. The terrifying aspect of this exile for scientists is the potential for gravitational instability within the solar system itself. While the stars themselves do not hit each other, a close pass by another star, even at a distance of a few light-years, could be enough to disturb the delicate balance of our outer reaches. Our Sun is surrounded by the Oort cloud, a vast reservoir of billions of icy comets and debris. A passing star's gravity could act like a gravitational nudge, sending a rain of these comets hurtling toward the inner solar system. Even if Earth were still a habitable world, This could trigger a bombardment far more lethal than the one that wiped out the dinosaurs. The exile of the solar system is not just a change of address, it is a journey through a gravitational minefield where a single near miss can have catastrophic consequences for the planets. This displacement also changes the chemical future of our neighborhood. In our current location, we are surrounded by gas and dust that is enriched by the deaths of nearby stars, allowing for a cycle of recycling and rebirth. But in the Ren outskirts of the halo, there is very little gas. The solar system would be starved of new material. We would be a closed system, a relic of a previous age drifting through a region of space where nothing new is ever born. The James Webb Space Telescope has observed rogue star systems in other galaxy clusters that seem to have been victims of this same process. They sit in the dark, far from the light of any host galaxy, cooling and fading in total isolation. These are the lost children of the cosmos, and they serve as a silent warning of our own potential fate. Yet, there is a strange, stoic beauty in the idea of exile. Being cast out of the galaxy would provide a perspective on the universe that no human has ever experienced. From the isolation of the intergalactic void, we see the true structure of the cosmos, the web of galaxies and the vast voids between them, unobscured by the glare of our own galactic home. We would be the ultimate observers, untethered from the tribalism of a single star system or a single galaxy. Exile is the final stage of our journey from the center of the world to the edge of the universe. It is a reminder that we are travelers and that home is a fleeting concept in a universe governed by the restless motion of titans. The James Webb Space Telescope continues to track the stars at the very edges of Andromeda, the ones that are already being teased away by the Milky Way's gravity. These are the first exiles, pioneers of displacement. By watching them, we are watching our own future. We see how their orbits are being stretched and how they are being prepared for their journey into the dark. The terrified reaction of the scientific community is a reaction to the loss of control. We are realizing that our solar system is a leaf in a hurricane, and the hurricane of the Andromeda merger is about to pick us up and carry us somewhere we never intended to go. As we conclude this chapter on exile, we must accept the precariousness of our position. We sit in the outer disk of a spiral galaxy that is about to be dismantled. Our sun, our planets, and everything we have ever built are subject to the whims of galactic tides. Whether we are flung into the void or relocated to the halo, the familiar sky is doomed. We are entering a period of cosmic migration, a forced exile that will redefine our place in the universe. The gold. N-Web mirrors are the only maps we have for this journey, showing us the paths of the stars that have gone before us. Darkness is coming, and the solar system is preparing for its long, lonely walk into the outskirts of the new world. In the profound silence of the far future, when the two galactic titans have finally merged into the singular mass of Andromeda, the final and most violent act of the drama will occur at the very center of the new world. It is an event that will make the collision of 1 trillion stars seem like a quiet rustling of leaves by comparison. Deep within the dense glowing heart of the elliptical galaxy, two supermassive black holes, one from the Milky Way and the far larger monster from Andromeda, will finally meet. This encounter is the ultimate destination of the merger, a culmination of billions of years of gravitational attraction. As these two singularities spiral toward one another, they will begin the final ringing of the space-time bell, a process that will ripple across the entire observable universe and announce the birth of a new cosmic era through the medium of gravitational waves. The two black holes do not simply crash into each other the moment the galaxies meet. Instead, they begin a long, slow orbital dance that can last hundreds of millions of years. As they plow through the thick clusters of stars at the galactic center, a process called dynamical friction begins to sap their momentum. Each time a black hole passes near a star, it flings that star away with incredible speed, losing a tiny bit of its own energy in the process. This causes the two monsters to sink deeper and deeper into the central well. drawing closer with every orbit. Eventually, they reach a critical distance where the stars can no longer drain their energy, and a new, more powerful force takes over, the emission of gravitational waves. At this stage, the two black holes are so close and moving so fast that they begin to physically stir the fabric of space-time itself. Einstein's general relativity tells us that space and time are not an empty stage, but a flexible fabric that can be stretched, squeezed, and vibrated. When two massive objects like Andromeda's 140 million solar mass black hole and our own 4 million solar mass heart orbit each other at a significant fraction of the speed of light, they create ripples in this fabric. These ripples, known as gravitational waves, carry energy away from the binary system, causing the orbit to decay at an accelerating rate. The whispering scientist describes this as the ringing of a bell. As the black holes spiral closer, the frequency and intensity of vibrations increases. The pitch of the space-time bell rises, moving from a low rhythmic hum to a high-energy chirp that signals the impending merger. This is the ultimate music of the spheres, a symphony of pure gravity that requires no air or medium to travel. It moves through reality itself. The James Webb Space Telescope, while designed to see light, provides the crucial context for the environment where this ringing occurs. By mapping the incredible density of stars and gas at the core of the merger, Webb has shown scientists the friction that drives the black holes together. We see the chaotic eddies of gas and the high-velocity stars that are being sacrificed to pull the two monsters into their final embrace. The data suggests that as the black holes get closer, the accretion disk surrounding them will become incredibly hot and turbulent. For a brief period of time, the center of Andromeda will likely ignite as a dual-active galactic nucleus, two glowing eyes of radiation staring out from the darkness. As they prepare to become one, the final second of the merger is a moment of violence that exceeds any other phenomenon in the cosmos. As the two event horizons touch, they merge into a single larger distorted sphere of doom. In that final fraction of a second, the power output in gravitational waves is greater than the combined light of all the stars in all the galaxies in the observable universe. It is a burst of energy so concentrated that if you were standing anywhere within the galaxy, the very atoms of your body would be stretched and squeezed by the passing waves. The space-time bell rings with its final, most powerful stroke, a ring-down phase where the newly formed black hole vibrates as it settles into a stable spinning configuration. This ringing eventually fades into a permanent, heavy silence, leaving behind a single black hole with a mass of roughly 144 million suns. What makes this terrifying to scientists is the sheer scale of the conversion. During the merger, several million solar masses of pure matter are converted directly into gravitational wave energy in an instant. His energy radiates outward at the speed of light, crossing millions and billions of light years. Long after the light of the stars in Andromeda has faded, these ripples will continue to travel through the void, a permanent record of the collision. It is the ultimate ghost of fusion. Furthermore, if the two black holes have different spins or masses, the merger can produce a recoil kick. The assaulting black hole can be launched out of the galactic center at thousands of miles per second, potentially leaving the heart of Andromeda empty and dark, while the monster drifts into the halo, still ringing from its birth. The LIGO and Virgo observatories have already achieved the detection of such events in distant galaxies. But the merger of the Milky Way and Andromeda will be on a scale that dwarfs anything we have yet recorded. It will be the Big Bang of our local neighborhood's final evolution. The James Webb Space Telescope has identified several pre-merger binary black holes in the distant universe that act as a preview for this event. We see the distorted light and the superheated gas that surround these systems, and we can calculate the exact moment when their bells will for the final time. We are watching the countdown for our own future, a mathematical certainty that is built into the very architecture of gravity. As the final ring of the space-time bell echoes into the intergalactic void, the The transformation of our local group is complete. The two galaxies that once defined our sky are gone, replaced by a single massive island of light with a singular massy. Fart. Ringing the bell is the announcement that the struggle is over. The whispering scientist observes that in the end, gravity always wins. It pulls the stars together, it pulls the gas together, and eventually it pulls the black holes together. The final ringing is a moment of ultimate unity, a point where the separate histories of the Milky Way and Andromeda are merged into a single eternal record. We are currently living in the quiet before this bell begins its final toll. The James Webb Space Telescope is our way of listening to the first faint whispers of the coming vibration. We see the way Andromeda's core is stirring, and we see how its black hole is beginning to interact with its surroundings. These are the early, tentative notes of the symphony, as the eons pass and the distance between our two worlds continues to shrink. The volume will increase. The terrified scientists of the present are those who have realized that we are part of a cosmic instrument that is currently being tuned for its final performance. The bell will ring, the fabric of space will shake, and the universe will never be the same again. Deep in the twilight of the cosmic timeline, billions of years from our current era, the universe has settled into a state of profound and haunting stillness. The violent collisions, the spectacular starbursts, and the frantic awakening of black holes have all passed into the forgotten annals of prehistory. What remains is Andromeda, a gargantuan, amber-hued elliptical galaxy that stands as the solitary monument to the long-dead Milky Way. Why and Andromeda? In this final chapter of our story, the whispering scientist observes a world that has finally found peace, but it is the peace of an empty theater after the final curtain has fallen. The sky is no longer a canvas of vibrant blues and swirling dust. It is a uniform, thick mist of ancient low-mass stars. This is the eternal quiet of the elliptical, a stage of galactic evolution, where the fires of creation have been permanently extinguished, leaving behind a fading ember that will slowly cool over trillions of years. To understand this final state, one must envision a galaxy that has completely exhausted its lifeblood. In its youth, Andromeda was a predator that grew by consuming the gas and stars of its neighbors, but in the era of Andromeda, there is nothing left to eat. The Great Merger used up every available scrap of interstellar hydrogen, compressing it into a final generation of stars that have long since burned out and collapsed into white dwarfs, neutron stars, or black holes. Without fresh gas to trigger the birth of new suns, the galaxy has entered a state of terminal senescence. The only stars left are the red dwarfs, tiny frugal nuclear furnaces that burn their fuel so slowly that they can outlive the age of the universe many times over. These stars provide the dim reddish glow that defines the elliptical galaxy. There are no brilliant blue giants to light up the night, no pink nebulae where new worlds are born, and no dark dust lanes to provide contrast. The galaxy is a smooth, featureless sea of red light, a homogeneous cloud where every direction looks exactly like the last. The structure of Andromeda in this final age is a testament to the ultimate victory of entropy. The organized, spinning disks that once defined our home have been thoroughly scrambled by the gravitational chaos of the merger. Stars no longer move in the rhythmic circular patterns of a spiral. Instead, they follow erratic, swarming orbits that carry them in every possible direction. If you were to stand on a planet orbiting a star in this era, the concept of a galactic plane would be entirely foreign. The galaxy would surround you in all directions, a spherical cocoon of light that never changes. This lack of structure is the hallmark of the elliptical galaxy, a system that has reached maximum disorder. The James Webb Space Telescope's distant observations of red and dead galaxies provided the blueprint for this reality, showing us that all large galaxies eventually trend toward this state of featureless stability. It is the final form of matter before the ultimate dark. As the eons continue to pass, Andromeda's isolation becomes stark, because the expansion of the universe is accelerating, driven by the mysterious force of dark energy. The space between galaxy clusters is growing faster than light can cross it. One by one, the distant galaxies that once filled our telescopes will slip over the cosmic horizon, moving so far away that their light can no longer reach us. Future astronomers in Andromeda, should they exist, would look out into a void that is truly and terrifyingly empty. They would see their own massive galaxy and nothing else. The billions of other light islands we see today would be gone, leaving Andromeda as the entire observable universe. This cosmic loneliness is the final psychological weight of the elliptical era. The connections between different parts of the cosmos have been severed, leaving our local group as a solitary survivor in an infinite, expanding dark. The supermassive black hole at the center, now a singular 144 million solar mass Titan, has also settled into a state of eternal quiet. With no more gas clouds to swallow, no more stars wandering into its immediate vicinity, the accretion disk has vanished. The monster is still there, a massive puncture in the fabric of space-time, but it is once again invisible. It no longer screams in X-rays or launches neutrinos into the void. It sits, in total darkness, at the heart of the amber mist, a silent gravity well that anchors the trillion stars of Andromeda. The whispering scientist reflects on the irony that the very object that once terrified us with its awakening has become the quietest part of the galaxy. The violence of the past has been replaced by a gravitational equilibrium that will not be disturbed as long as stars keep shining. The fate of our own solar system in this era is one of quiet fading. Whether we were relocated to the distant halo or remained in the inner swarm, our sun will have long ago collapsed into a cold, dark crystal of carbon and oxygen, a white dwarf. The planets, if they weren't destroyed during the sun's red giant phase, will be frozen cinders orbiting a star that no longer provides heat or light. We will be part of the ancient population of Andromeda, a tiny, insignificant part of the amber glow. There is a profound sense of finality in this vision. Everything that humanity ever strove for, every war fought, every song composed, and every discovery made, occurred during the brief flash of the spiral era. The era of the elliptical is vastly longer, a trillion-year twilight, where the universe slowly runs out of energy. It is a time for reflection, not action. The James Webb Space Telescope was the first instrument to truly enable us to read the map of this destination. By looking back in time at the oldest galaxies, it showed us the beginning, and by looking at the most evolved ellipticals, it showed us the end. We are the first generation of humans to understand the full arc of our galactic biography. We know that the beauty of Andromeda is the precursor to the violence of the merger. We know that the violence of the merger is the precursor to the eternal quiet of the elliptical. The terrified scientists we discussed in the beginning were those who looked at the data and saw the mortality of the galaxy itself. They realized that even stars have sunsets. As we conclude this long and haunting journey from the golden mirrors of Webb to the amber mists of the far future, we are left with a sense of awe at the scale of the cosmos. We have watched a galaxy wake up. We have seen the monster at its heart. And we have witnessed the collision that will define our destiny. The story of Andromeda is the story of the Milky Way, and the story of the Milky Way is the story of us. We are witnessing the transition. We are the ones who looked up and dared to ask what the smudge in the sky really was, and in doing so, we uncovered the blueprint of our own transformation. The eternal quiet of the elliptical is not a death but a rest. It is the final state of a system that has completed its work. The trillions of stars have been born, they have lived, and they have been gathered together into a single massive family. The whispering scientist reminds us that while the dark is inevitable, the light is magnificent. The 4 billion years we have left as a spiral galaxy are a precious gift, a time of vibrancy and motion that we are lucky to inhabit. As you look up at Andromeda, Tony, do not just see a distant threat, see a future companion. See the other half of the world that is waiting to meet us. The collision is a beginning as much as an end, and the silence of the future is the final peaceful note of a symphony that has been playing since the dawn of time.